Verdict 2B.
잠시 안내 말씀드리겠습니다. 잠시 후 10시부터 2023년 대한공간정보학회 추계학술대회가 시작될 예정입니다. 오늘 컨퍼런스는 GIS 월드 유튜브 채널에서 같이 생중계되고 있으며 오후부터는 서울시 채널에서도 생중계될 예정입니다. 아울러서 서울 도시건축 전시관 및 길 건너에 있는 시민청 내부에서는 취식이 금지되어 있습니다. 커피와 다가는 1층 카페나 혹은 옥상 마루에서 하여 주시면 감사드리겠습니다. 잠시 후 10시부터 컨퍼런스를 시작하겠습니다. 잠시만 기다려 주십시오. Ladies and gentlemen, may I have attention please? Today's conference is being live streamed via the GIS World YouTube channel. Thank you. There are some people not arrived yet, so we have 10 minutes. After we have 10 minutes start. Thank you. 이제 개회식을 시작하려 합니다. 위에 계신 분들은 여기 내려오셔서 착석해 주시면 감사드리겠습니다. Good morning, ladies and gentlemen. Welcome to conference of Korea Spatial Information Society. My name is Park Kyung-sik, professor of Inner Technical College. I'm honored to be the master of opening ceremony of this conference. For the smooth process, I kindly ask you to turn off your phone or silent mode your phone, please. Thank you for your cooperation. Now, let's begin the 2023 conference of Korea Spatial Information Society. You have invited two speakers for the keynote lecture. The first keynote speaker is Hwang Ji-eun, who is professor of University of Seoul and also CEO of Tech Capsule. She will speak on the lucid heritage, digital representation, and archive of urban fabric. Please welcome her with big hands.
Thank you for having me and inviting me and being here in a cold weather. I'm so excited to share my clumsy idea of the concept of lucid heritage with you. 마우스가 안... Okay, the first session's a destiny. Imagine a city as a live canvas where the past and present are interwoven in the intricate tapestry. Lucid heritage is about consciously navigating this urban fabric, preserving our cultural roots in the face of rapid urban development. Indeed, I took this idea from lucid dream. I take this image from the movie Inception, where you are aware of your dreaming and you control your dream environment, right? So, likewise, lucid heritage is about being consciously aware and purposeful, and as our city transforms, it's like a city in a constant state of flux, and lucid heritage allows us to be lucid and fully aware of this change. Just as you might shape a dream consciously in a lucid dream, lucid heritage let us consciously document, archive, and understand the change in our urban fabric. So lucid heritage is the idea of being aware, intentional, and mindful in how we approach the preservation of our cultural and historical heritage within a contemporary dynamic context of urban development. As you can see, it's beautiful images from maps. City is a vibrant and dynamic tapestry, woven together by various elements like buildings, streets, and parks, and neighborhoods. And this intricate and interconnected pattern, the urban fabric, I would say, that forms the overall structure and character of the city. Think of it like a quilt It's a traditional Korean bojagi made of diverse patches, each representing different part of the city. Some patches showcase the historic buildings, while others depict skyscrapers, streets, like a thread that connect these patches, creating a seamless and unique design. Now, for visitors, I would like to look at some Seoul urban fabrics. This is Dongdaemun area. As you can see, the major road system and streams is over there, and then the infill of the block is a little bit different. Some are follow the more ancient the alley systems. Some are new development, and obviously there is a big object, Dongdaemun Design Plaza as a monument, and then that also influence all the road systems and other about district. And then there are empty big plots waiting for the development. Is like obviously a patch of our life. And this is Jamsil area, and as you can see, there's tallest building in our country is there, and then you can see all different types of beautiful patterns of infills with the residential development, as well as like mixed use. The small buildings is located in a wall. Also, there are, the development is going on. It's big, mega residential complex projects. And now we are here. This is Seoul Hall of Architecture and Urbanism, where you're sitting. And check out this SMAP interface. I saw many advertisements of SMAP before this session started. Maybe the big sponsor today. So this is a Seoul public digital twin. And as you can see, this building used to be 5-story buildings, and then that is reconstructed in between 2030 to 2022. So it's about adjacent with one of the royal palace in Seoul. There are 5 royal palaces within this area, Deoksugung. And then the main boulevard, the Sejonglo, is reached all the way up to Gyeongbok Royal Palace, and then Gwanghwamun area. So this must be to go if you visit. Firstly in Korea, that's the national monument place. Gwanghwamun is the main gate of Gyeongbok Palace, and then Gwanghwamun is the Gyeongbok Palace built in 1355, the 14th century, and then more than the historic landmark, Gwanghwamun is a symbolic public space representing the culture and democratic essence of Korea. Just a month ago, the restoration of Gwanghwamun's Waldae, the primary podium structure of this historic gateway, was successfully completed. Referring to the original structure from Joseon Dynasty in the 14th century, this restoration project aligns with the rich history of Korean modernizations. Over 600 years, but more recently 100 years, during 100 years of modernization period, Gwanghwamun has been evolved and undergoing multiple reconstructions solidifying its status of national monument. At the recent restoration project, excavation around Gwanghwamun discovered various evidence of a modern urban infrastructure trace, such as tram rail operated until 1966 from a Japanese occupation period. Also, foundation of ancient buildings from 18th century, and water and sewage pipes from Joseon Dynasty era to the present. However, this tram track remnant has been relocated to railway museum, and then other infrastructure elements has been revaried because this aim to get back to 600 years original status. Thankfully, the city of Seoul has documented the 3D scanning records of this excavation site, including the tram track route, as part of this process. This captured 3D data of the excavation site represents just a momentary state of the city. However, it conveys rich evidence stories and that penetrated the history of contemporary urban environment until now. Well, here comes a common challenge in Asia. Rapid urban development reshaping cities at an unexpected or uneven pace. Traditional heritage often gets overshadowed by skyscrapers. Also, modern structures, even worse, from let's say 1950s to 1990s, can be even fragile since the status of heritage is not considered for the less old structure. And deciding whether to preserve or demolish becomes a very hot topic, influenced by the tension between real estate economy or cultural and political policies. Take a Seon district case in Seoul, a paradoxical mix of modern and historic. It's a very unique urban manufacturing ecosystem that evolved over 50 years, despite of the redevelopment pressures. It consists of 1 kilometer long Seun-sanga complex, which is one of the modern pioneers of mixed-use residential apartment, and it's surrounding 8 blocks of urban manufacturing area. Seun-sanga, the first Seun-sanga was built in 1967, and it stands next to the World Heritage Jongmyo Shrine, and the patterns and streets and buildings plots stays there, although all the mayors have renewed master plans of this central business district. Over time, the urban manufacturing field with the small factory alleys become very unique characteristics as production ecology. Creative industries such as design, art, and film are growing together in this area. How do we capture this capture and navigate this intricate urban fabric? Enter the design digital twin approach. The Lucid Heritage embraces the idea of creating digital representation reflecting the current state of the city and the layers of history within it. This digital representation is not a passive archive, it's a dynamic tool that allows us to explore, understand interplay between traditions and modernity. Lucid Heritage actively engage with the urban environment, capturing not just what it is, but what was and what could be. This presentation I showed was done by a grassroots documentation project by 3 groups. It was a proactive survey by 3 expert groups of the technologists, architects, and archivists. We voluntarily initiated collaboration in the urgent risk of demolition of this area. So there's some glimpse of how the survey was. So 3 teams take a role. So in-depth interview how the factory owner have been changed their environment through their occupancy, and then the architect make some clues that sometimes it turned out it's very traditional Korean architecture, sometimes not. And then their story also very creative, how they struggle with their working environment within that urban environment. Also, my team, Tech Capture, took a role, make a 3D scan it, so give the basic information for the survey team. So the ethnographic survey team use this information first, and then also the urban infrastructure here is very outdated, so it's hard to get the accurate map in this center of Seoul area. So it
이미
takes
살고 계신
also
분들이 다 빠진 비어 있는 건물인 경우도 있지만 그렇지 않고 이제
the survey researcher just talk about the importance of these collaborations, because we had to enter the factory that is working. So we need somehow like personal relationship with them. Also have to investigate more in-depth investigation of that environment. So the time was very consuming, but it took a very precious time to understand this area. Currently, the urban fabric of Seoul is undergoing massive reconfigurations. Within it, the risk of losing elements that make our city unique even before recognize its identity. So this is the current future of Seoul district from the Seoul urban plan. It prompts us to ask, what do we value as heritage in our cities today? How we can consciously integrate into this development narrative, and what do we lose and what do we gain? I will take another example. It's Bampo apartment reconstruction project. So it's actually already demolished for new reconstruction. It was originally developed in the 70s for public housing, tightly related to history of urban expansion toward Gangnam of Seoul. Now it will be reconstructed for one of the most expensive residential high-rise complex. Last year, we contacted to the resident union, Johab, and the construction company in order to get permission to documenting this complex. Right after all residents moved out and before the construction started, we gathered volunteer teams of radar scan, MMS, drone 3D mapping to investigate, record this technique on this various detail of this complex. So let's take a look how we mingle this data with some like interview narrative by the patrols of this the last moment of this complex. So it was autumn, very beautiful coloring of the whole parks, and then whole scene is already gone, and that can be a lucid heritage of our time. So this work itself was volunteered work, but before that there are many precedent research that, for instance, Seoul Museum of History already has like interviews of these residents, and they published with this. So we took that unit who interviewee exist as a more detailed VR, and then we take one whole building with MMS 3D scanning to take this for the future precious resources for urban planning and our culture.
주로 이제
So-
건축, 톰
For the time, you can find out YouTube of tech capture. So there are many other movies about the lucid heritage that we are losing in our time. So lucid heritage is not just a concept; it's an action. As if open source movement is a call to action, it challenges us to be aware, intentional, and proactive in shaping the future of our cities. By leveraging digital technologies to create dynamic representations, we can bridge the past and present, ensuring that our cultural heritage remains an integral part of our urban narratives. Those two digital documentation projects I showed are not yet on digital twin yet. They are good model and representative models capturing vivid facets of the city, and with enough data to technically craft into digital twins. A digital twin can serve not only as the most up-to-date data set, but also as a platform that proactively records and anticipates this interconnected urban environments. In essence, it can connect the past and the future, weave together people and the environment, and aggregate individual stories into collective history on the making. How can we transform data produced and created by the private sector like us into public data and experiences, and converting them into fundamentally the collective memories? The individual relationships between places and memories ultimately create the topography of collective memory of our time. And being aware, being intentional and mindful of this topography is the process that ultimately sustains our city. As we navigate the evolving urban landscape, let us embrace lucid heritage as a guiding principle, one that encourages us to learn from our own history, respect our heritage, and consciously shape the city of tomorrow. Thank you.
Thank you. Thank you for interesting presentation. Now we have Q&A times for 5 minutes or 10 minutes. As you know, this ceremony started 10 minutes late. So if you have any questions. Yeah. Thank you, Professor Wang. Yeah, let's give a big round of applause to Professor Wang. Thank you very much. Now, next speaker will be delivered by Ms. Dina Faye Ander. She is a regional ambassador of youth members in Asia Pacific region and also research in NOAA Center, University of Philippines. The topic of lecture is modern map makers, the power of collaborative mapping in shaping our modern technology. Please welcome her with big hands.
안녕하세요. Yeah, that's the only word I know. Yeah, good morning, everyone. Yeah. So for this morning, I'd like to thank the organizing team of the FOSS4G Asia and also to everyone who is around here to listen to our talk. So for today, I will be discussing and sharing with you my role in the OpenStreetMap community and how it impacted my life and how our mappers in the community, our modern map makers in the community have been shaping the future of the modern technologies. So let me further introduce myself. So my name is Faye, and I'm a volunteer of OpenStreetMap from the Philippines, particularly in Metro Manila. And beyond my role in the OpenStreetMap community, I'm also actively involved in different smaller mapping communities, such as Geolidis Philippines, who is actively involved in working with women in the geospatial technologies and recruiting more women mappers to contribute to the OSM data. And I also co-lead a chapter of youth mappers in the University of the Philippines, Resilience Institute. And I am a regional ambassador of Youth Mappers since 2020, where we actively recruit student organizations to be involved in the open data movement. And also, I am a voting member of the Humanitarian OpenStreetMap team. So let me share with you some of my journey as a volunteer of OpenStreetMap in the Philippines. So I owe it a lot to my former supervisor, Maning Sambale, because he was the one who introduced me to the OpenStreetMap community. So in 2013, we worked in a project in the Philippines, particularly in the province of Pampanga, where we work with the local government units to map different areas in their province. So we mapped here the critical facilities such as the hospitals, the educational facilities, and other facilities that are very critical for disaster risk reduction. And we introduced some technologies like QGIS, like field papers, OpenStreetMap data, for them to be able to use it for their disaster risk reduction and management plans. So thank you, Sir Maning, if you're watching live. Thank you because for introducing me to the OpenStreetMap community. And without you, maybe I will not be here also with you today. And in 2013, it was also the same year when Super Typhoon Yolanda hit the Philippines. So Yolanda was one of the biggest typhoons that happened in the Philippines because it also destructed a lot of facilities, establishment, and also there were a lot of casualties that happened. And to quote Eugene Villar, one of the active member of the OpenStreetMap Philippines. He said that before, the OSM Philippines community was a very small group of hobbyist mappers. So as you can see on the screen, we have here photos of the previous mapping parties held in the Philippines. And you've also noticed here that there is a very small ratio between men and women in the community. In fact, I think there is even less than two women who were part of the mapping parties, were part of the community of OSM Philippines. But because of the crisis brought by Yolanda, it showed us that the work we do in the OpenStreetMap community and in OpenStreetMap ecosystem showed us that Philippines or mapping using OSM can mean the difference between life and death, because these datasets were used by different organizations, humanitarian organizations, in the response to those affected areas. And to show some statistics of how Yolanda helped us in increasing the map data of OSM in the Philippines, around 1,670 volunteers mapped in the Yolanda corridor area where the Yolanda happened, and 82 countries from all over the world also helped us in responding to these areas, and around 4.5 million objects were mapped using OpenStreetMap. So a lot of contributions from different volunteers across the world helped us in responding to those kind of crises. And furthermore, there was an extreme spike in the growth of OSM data in the Philippines. So since our community before was very small, and because of Yolanda, it has led to an extreme spike, making it more increased data sets in the Philippines in terms of building footprints, relations, nodes, etc. And apart from my involvement in the OSM Philippines community, I also work in an academic organization where we also use and utilize OSM data for our disaster risk reduction and management, and even in our analysis. In fact, in 2016 and in 2017, we used OSM data and mapped 17 provinces across the Philippines, so that we can also use it to analyze whether those building footprints, whether those roads are affected by different hazards such as floods, landslides, and storm surges. So with the help of our volunteers from different organizations, including the students from the university, we were able to gather 452 volunteers and map 2.7 million buildings across those provinces. And until now, it's 2023, we've been using OSM data furthermore to be able to instantly show people how these buildings and these areas are impacted by these types of hazards. So here we have in the Philippines Know Your Hazard component under also of the NOAA website, if you can also check it. It instantly assesses the building footprints or the area based on its exposure to different hazards. So OSM datasets are very used even in the government and even in the public sector. And as you can see before, we only have a few men and women joining the mapping parties. But since my active days or early days of involvement in the community, it has widely expanded. So as you can see here, more women are joining our mapping parties, more groups from the LGBT and minority groups are joining us and celebrating the beauty of open data. And since OSM community is also growing and it has a crucial role in the disaster risk reduction and management sector, I would like to acknowledge the humanitarian OpenStreetMap team because they have established open mapping hubs across the world because it was driven by an enhanced appreciation of OpenStreetMap, and it also underscores the growing importance of collaboration among the different regions, and it also strengthens the regional collaboration among the countries here. So Open Mapping Hub is also a sponsor of the FOSS4G Asia conference, and they are very active in terms of providing support to different communities in Asia and across different regions of the world. And aside from the mappers from the humanitarian sector, we also have our modern map makers, who are the youth mappers. So there is a common saying that the leaders of tomorrow or the future are the youth. But we believe that youth mappers or the young generation are the leaders of today because they are already actively taking the role of leadership in collaborating with different communities and also in mapping the different areas of the world. So if you're not yet familiar with Youth Mappers, it's an international consortium of university-level student organization from different parts of the world. So we have over 5,000 students and alumni working with us, and from 388 university campuses from 80 countries. And we're also proud to share that 45% of our community and network is women. So it's at least it's growing and it's also progressing. And we work with various countries, and also we work directly with the communities because they have been actively collaborating with us in helping them enhance the data sets in their country. So for instance, in Asia, Bangladesh, Nepal, and the Philippines are the countries that are most active in terms of the contributions in the map data and also in expanding the reach of OpenStreetMap within their respective countries. And furthermore, to zoom in to my country in the Philippines, I also owe it to the Youth Mappers community because they have elevated my presence to the OSM community, helping us reach those invisible areas so that they can be visible to the map later on. When I started working with Youth Mappers in 2018, there were only 2 chapters in Metro Manila or in the Philippines. But because we don't want invisible things on the map, we tried to expand the reach of OpenStreetMap and Youth Mappers across the Philippines. That is why we actively collaborated with the Youth Mappers or the universities in the Visayas, here, and in the Mindanao regions because they also need help in expanding the data in their respective communities. And in Youth Mappers, we invest more in the capacity and skills and knowledge of our young mappers. That is why we do a lot of capacity building for our mappers so that they can also teach other communities, they can serve other communities so that we can create more maps to the benefit of the community. And we also try to serve as diverse communities as we can so that we ensure that everyone can be visible to our map data. So in these pictures are some of the active Youth Mappers chapters in the Philippines. So aside from actively contributing map data to OSM and mapping during crisis, their interests also expanded not only for disasters but also according to their advocacies. Some of them partnered with elderlies because they wanted to help elderly to be able to locate which services are capable of serving them. And our vision and mission also aligns with the United Nations Sustainable Development Goals. So this is testament that collaborative mapping is helpful in addressing these kinds of goals. So through our local chapters across the world, we've been providing support with different communities conducting chapter mapathons. So we call it mapathons, where we gather a small group of people and do same or shared goal, which is to map areas that are affected by a crisis. And we also do a lot of community outreach activities so that we know that our work is directly impacted for those communities. And last year, we have published a book, an open access book called Open Mapping Towards Sustainable Development Goals, where we shared the voices or stories of how youth mappers work with different communities in addressing sustainable development goals. So in particular, in the Philippines and in Asia, we work under Sustainable Development Goal for Health, which happened during the pandemic and also during crisis when, of course, when disasters are happening. And I just want to highlight how the passion of OpenSeatMap volunteers are also impacting us, because volunteering during the pandemic isn't very easy because there are risks involved when going out and possibly being affected. But I want to commend the mappers that we work with during the pandemic and map those areas that can be affected during those times. So the spirit of volunteering remains intact even during this crisis. Also, earlier this year, we worked with some communities in Turkey and Syria, since they were affected by an earthquake in their respective countries. And here, youth mappers took an active role in organizing mapathons, mapping activities, so that we can contribute to the map data and help in the disaster response in Turkey and also in Syria. And aside from youth mappers, there are also coordination among different international organizations, such as Humanitarian OpenStreetMap Team, Open Mapping Hub, IFRC, Missing Maps, and so on, who work together for a shared goal, which is to provide open data, accessible data to those organizations that can help in responding to those affected areas. Let me play this video so that you can see the amount of contributions by volunteers of OpenSeatMap community. So for this particular response, we were able to map more than 2 million buildings, and more than 1,000 volunteers also contributed to the map data. And collaborative mapping also has given birth to an array of different mapping tools in the OpenSeatMap community. And we are very grateful that they have been very supportive since day one, since there are tools evolving, and also there are tools that were developed using also collaborative community. So we have ID editor, we have street level imagery using Mapillary, we have organic maps for mobile data collection, we have the rapid editor that utilizes AI generated building footprints and also roads, and some other applications like OSM and Open Aerial Map and Everydoor. So we're very grateful to those big organizations and companies that continuously support OpenSeatMap community. And also for us, as these technologies modernize and develop, it also undergoes a symbiotic relationship, because we also benefit from the development that they've been doing and from the ever-evolving landscape of technologies. So we've been actively using the AI-generated images so that we can also contribute in validating the data from those kinds of technology. And just to share how our communities help in increasing the data of in the Philippines, I will play this small video. So again, we started mapping in 2009, but as you can see from the video, because of the active involvement of different communities, we were able to expand the data sets across the Philippines, making this data accessible to everyone. And as we acknowledge that our communities has been growing, a lot of smaller communities have joined the community, we also have to take note that we have still a long journey to go, because there are still opportunities for innovation, for collaboration, and more impact to the communities. And maybe before I conclude my presentation, I just want to leave an important note, especially to the members of the Open Data movement, particularly the volunteers. So if you feel tired, exhausted from all the volunteering work that you do, please remember your why. Remember why you started in the first place. So this is a small story I got from a student from the Philippines as well. So she messaged me, I think this was 2 years ago, because she took an exam for her geodetic engineering licensure, and I was surprised that I got this message that I was able to inspire her, not knowing her personally, but I think my impact to the community has expanded, so that I didn't know that I was that kind of inspiration to those kinds of people or students. So if you're tired, if you're exhausted, and if you don't know what to do, just remember why you started it, and remember the impacts that you've had in your community, the collaborations you've formed, and your purpose. So that's all. Thank you so much, and if you have any questions.
Thank you so much, Ms. Dina Fay. Also, we will have Q&A times. If you have any questions. Yes.
Thanks
Please.
for your great presentation this morning, early this morning. Actually, in Korea, we have some kind of legal obligation to collect the geospatial information over the street or building or stuff like that. Is there any legal restriction in the Philippines? You know, as a volunteer, you might have some, permission from the Philippine government to gather that information and store and to distribute to other parties. So I believe you should have some kind of permission from the government. Or what's the process in the Philippines?
There is no actual legal rule to follow when mapping using OpenStreetMap. But when working with, for example, private subdivisions, we have to ask permission from the homeowners to go inside their subdivision and collect data sets. But in general, we don't ask permission from the government. In fact, we also wanted to collaborate with the government of the Philippines, so that they can also utilize OpenStreetMap data for the entire Philippines.
Okay, Professor Han.
Hi. Thank you for your presentation. Do you feel cold? Do you feel cold? Yes, I've been Manila a few years ago. I feel very warm in there. I heard very interesting. You have good idea. The most important thing is sustainable development. Then Please tell me about your future plan shortly. Please tell me about your future plan. Yes.
Thank you very much for that wonderful question. So for me, for next year, I plan to conduct more capacity building with the Youth Mappers chapters in the Philippines, but also across Asia, so that we can support elevating the skills and their knowledge to be able to contribute more and to validate more data. Because right now, there have been a lot of existing chapters already of youth mappers, but we also want to focus on enhancing their skills so that we can maintain and ensure the high quality of data in OpenSeatMap.
Yeah, having more questions? Thank you, Ms. Dina Pei. Yeah, let's give a big round of applause to Ms. Dina Pei for giving a great lecture. Next, Mr. Park Soo-hong, President of Korea Special Information Society, will deliver his opening remarks. Please welcome him with a round of applause.
Good morning. It's very cold today. Yeah. KSIS members and distinguished guests and two wonderful keynote speakers. Welcome to 2023 KSIS Fall Conference. I'm Soo-hong Park, the president of Korea Special Information Society, and I'm very honored to have an opportunity to address you today. First of all, I would like to express my sincere gratitude to all of you for participating in this KSIS conference. This is a wonderful week as the KSIS is co-hosting the FOSS4G Asia 2023 conference with the Seoul Metropolitan Government and the OSGeo Korean chapters. FOSS4G Asia is an international conference that shares the latest technologies and trends in the global open source special information field. This 2023 Seoul conference is the first to be held in Korea, and it is expected to attract more 200 participants from more than 20 countries around the world. This KSIS conference is being held as part of FOSS4G Asia, and it will feature a variety of papers and seminars on open source special information technologies. It will also be an opportunity to share the latest research trends and technology trends through lectures and discussions by domestic and international spatial information experts. Spatial information is becoming an essential element in all areas of our society. Key technologies of the fourth industrial revolution, such as autonomous driving, smart cities, and digital twins, are all based spatial information. The KSIS recognize the importance of spatial information and is committed to the development and dissemination of spatial information technology. This conference is part of these efforts, and it will be an opportunity for domestic and international spatial information experts to gather and share the latest research results and to explore the future direction of spatial information technology development. I hope this conference will contribute to the development of spatial information field and help the sustainable development of our society. Once again, I would like to thank you all for attending this conference, and I hope you to have a pleasant and memorable stay in Seoul. Thank you very much.
Thanks so much, President Park. And that's for the opening of 2023 Conference of Korean Spatial Information Society. A big thank you all who shared their insight. And after lunch, the paper presentation will continue in the workshop room in Citizen Hall starting at 1:30 p.m. Thank you, everyone. Enjoy your meal. Thank you very much.
It's on. Can people hear me? Oh, excellent. Good afternoon, Seoul, Korea. My name is Jody Garnett. I'd like to thank my employer, GeoCat, for the opportunity to be with you this afternoon. And I'm here representing the Open Source Geospatial Foundation, and it is my pleasure to be your session chair this afternoon. I'd like to start off by introducing Jason, I'm going to get your name wrong, Jason Singh, to talk about the state of MapLibra. Over to you.
Hello everyone, good afternoon. Hope you had a great lunch. This mic it's too cold. Everything is just so cold. I just can't handle the cold if everybody gets me. Okay, so my name is Jashanpreet Singh. I go by Jason Singh because that's what I deal with on a daily basis. You can say it's my dev name or my English name. So I'm going to be talking about MapLibra, state of MapLibra, everything that is happening in and around MapLibra, the community, the projects that are in progress, and how it all started. Okay, so MapLibra community. MapLibra is a completely community-based project, and we have the community spread out throughout the world. I'm the one from India. You can see a bunch of people from Europe, even in Japan, Korea, all the people, and 80 plus contributor, and people do it as a hobby and a professional, and everybody who is involved has a passion, a great passion for maps. So this is the MapLibra organization governing board. You can see like this is done on an election basis that they meet and they talk about what they take directions for MapLibra project, what we're going to do, which projects will take which funding, and how to manage the sponsors and all of that stuff. Right. These are the two main projects that MapLibra is supporting. MapLibra GLJS, which was the first initial project, and now MapLibra GL native support for C++, Node.js, Android, iOS. Yeah, so these are the two main projects, but MapLibra has further projects supported in React Native and Rust-based project also. These are the two main projects that MapLibra is working on. Right. This is the timeline of how MapLibra came into existence. MapLibra is based off a fork of Mapbox before when they were open source. So in December 2022, the MapLibra forked from, MapLibra was born from a fork of Mapbox. 2021, we migrated to TypeScript. So now it's a full TypeScript support. Terrain 3D model is available in MapLibra GL. Governing board was assigned. The first initial members came into picture, like who is going to be taking care of the projects, who will chart, who will take the direction of which direction the project is going to go. Professional maintainers hired. So this, like with MapLibra, all the funding that we've got from a bunch of sponsors have now been assigned to a bunch of features and maintenance, and professional people, like they're getting paid to maintain the project. And very recently in September 2023, there is Metal early access release for iOS. So now there is Metal support for the iOS operating system. This has been the timeline for Mapbox. So anybody and everybody who is sitting here, or if you know anyone, can get involved in MapLibra. The easiest way to check out what MapLibra is doing, which projects are the most active ones, who are the contributors, is to check out the GitHub. Or if you're already in the OpenStreetMap channel, you can search for MapLibra, and there are specific topics for GL native and GL native and Rust-based system as well. So you can check in every second Wednesday of the month. We have meetings discussing about MapLibra project directions, features, anything that's going to be worked upon. So anybody and everybody can join, right? So these are some of the contributors at FOSS4G. Brandon sitting over there. Ian is also here. Myself is also here, and maybe next time you will also be one of the contributors in MapLibra. Reach out to Brandon, Ian, or me to talk about anything MapLibra related, how you can contribute, how it can work for your use case. Again, it's a drop-in replacement for Mapbox. If you are looking to move away from Mapbox to an open source license, then MapLibra is your project, right? This is something I want to talk about, MapLibra bounties. So working in open source is often a bit challenging from the financial side of things, how how people are going to get livelihood out of it. So MapLibre has a bounty program, right, for all the projects. So you can go, you go back to the link mentioned here, step-by-step bounties guide, and see what features have currently assigned bounty to. Even if there is a bug or there is a feature that you would want to have, which doesn't have a bounty right now, you can go to the Slack channel, you can talk to the maintainers, and they will assign a bounty to it. Bounty can range anywhere from $100 to $2,000 depending on how much time or how complex the task is. So again, I really want to mention that you can get paid to work on MapLibre thanks to our sponsors and all the funding that we've got from the community. Right. Some of the features that I want to highlight from the MapLibre that currently the MapLibre has is, sorry. Yeah. So single style for both web and mobile, easy customization. The styles sheet, the spec is really easy to understand, and you can really get a lot done with just the style sheet. There is fast rendering support by the GL support and Metal support on iOS. This is the newest feature that is available in MapLibre. Yeah, so using MapLibre, it has a bunch of examples on the link that is mentioned there. It has examples for 3D animations, for 3D animations, markers, raster, video. Even if you want to put video on the map, that is available there, so you can check out all the examples. And there is also a repository of all awesome MapLibre, where you can check out how community and how the other companies are using MapLibre in their own use case. Right? It's as easy as getting started with MapLibre with this. It's like the basic map, it'll draw the basic map, and that's it. There you go, like the map is ready. The example is for MapLibre GL.js, but it's very simple to do this in your native apps as well. Right? These are the sponsors who are currently sponsoring the development of MapLibre, AWS Meta, Murin, who's a company, is also here. Komoot, Radar, and Jog Maps. Thanks to all these sponsors, the MapLibre project is growing strong and strong every day with increasing list of volunteers, with increasing list of features that we're adding, bugs getting resolved. Again, some of the quotes that I got on using MapLibre, especially from Brandon, it has a protocol called Add Protocol, by which you can have your own custom resource that you can use to load maps. So that works for proto maps, but it can also work for offline maps, or your own implementation of how you want to load maps onto the maps in MapLibre engine. There is dynamic styling involved. And again, same style sheets for web and mobile. And it's a drop-in replacement for Mapbox. So if you have vector tiles, if you're working with vector, it will work with the industry standard Mapbox vector tiles. And again, it's open source, so you don't have to pay anyone anything. And that's it from me. Thank you.
You told me that you might be finished a little bit early, but that was super quick.
Yeah.
Is that just a reflection of like your rendering speed or something?
Yes, it is.
It's just so
also
fast.
My own speed and my rendering speed, yeah, and the MapLibre is my rendering speed.
Okay.
And we also started off a little late, so I spoke a little really fast to get this thing done.
You certainly have some time for questions.
Yes. Anybody, any questions? Just if nobody's asking, then I would really like everyone to get involved in the MapLibre project. It's still it's a very mature project that you can use in production, but it's still missing a lot of features that I would like everyone to contribute to. Everybody bringing their own expertise from different backgrounds. So please try to join the Slack group at least, and lurk around and see if anything that you can work with in the MapLibre project. Yeah.
Okay. Well, I can ask a question. My project, GeoServer, actually has a Mapbox style rendering. It can read the Mapbox style format and configure GeoServer to draw with that. Is that something, I would love to convert that to MapLibre. Is that something that we could talk to your bounty program about funding?
Yeah, sure. I mean, talk to the people, or just use ChatGPT, I think.
Okay.
Put the JSON file, it'll throw the JSON file.
Okay, it would
Yeah.
just be really nice for interoperability.
Yeah, sure.
Yeah. Okay, I asked a question. Now it's your turn. Someone have a question.
Quick question about plugins. Do you can you talk a little bit about MapLibre plugins?
So I talked about the ad protocol that is already there, with which you can load your own, like you can do your own implementation of how you want to load maps. So that is there. Going forward, I think there will be a focus on plugins, I think, but not sure. Yeah. Anyone, anything else?
Hi, thanks for the talk. I'd like to ask about you guys' stance on the recent Mapbox style change. So, like, I believe Mapbox have released a new version and they have different kind of expanded style specification.
Yeah.
Like, how you gonna are you gonna handle them? Like, oh, what's the direction you're gonna?
So the project is now a separate project from Mapbox. It started as a fork of, but now it's a completely different project. So yeah, the MapLibre, it's going to do its own way.
Okay, so you guys are not planning to.
Not sure.
Okay. Okay. Thank you.
And I should point out that that is a real strength of open source, that freedom to fork and to set up your own governance to take care of a code base is a real fundamental strength of the open source approach. And it's something you should keep in mind, especially as kind of more and more Silicon Valley startups promote this business software license. Just MapLibre is an excellent example of why we fully embrace open source as a really good approach to engineering and trusting each other.
Yeah, and the way I got involved in MapLibre was that we already had a project set up in Mapbox. And once they changed the license, like a few years back, we were looking for an open source alternative, and MapLibre came into picture, and it was just like changing an import statement and a keyword, and that's it. We had a map running, which is completely open source, and to this day, it's still running in production and it's doing great. Yeah.
Thank you very much for the work you do and sharing your work with us today.
Thank you, everyone.
So I'd like to invite our next speaker to the stage, who's going to speak to us about the Cypress testing framework.
Hello. 안녕하세요. It's cold. Okay. Hello. My name is Palishat Navishian. I'm automated. And now I'm QA and automate test in iBit company Thailand. And okay. Okay, actually, this content might not be especially related to GIS, but it's important to helping and improving the mapping application is called automate test on web map application with Cypress. This may not be best practice, but it's guideline that I have summarized from what I have experienced that developing mapping application. And now, let's move to the first topic, my presentation. Okay, importance of testing. One, quality assurance. Testing helps ensure that a product or system meets specified quality standard. It identifies defect, issue, or vulnerability that might affect the product's performance or safety. Two, bugs and error detection. Testing is an effective way to find and fix bugs, error, and defects in software, hardware, or other products before they reach end user. This can save time and result in this long run. And 3, risk mitigation. Testing helps mitigate risks associated with product fail. Identify issue early in the development process can prevent costly recall, safety hazards, and reputational risks. And next, verification and validation. Testing verify that a product or system meet its design specification and validate that it fulfill user requirement. This ensure that end product does what it's supposed to do. And 5, user satisfaction. Testing is essential to ensuring that a product or service meet user expectation, and acceptance testing involve real user assessing the product usability and functionality. And 6, security. Testing help identify vulnerability in software or system that could be exploited by malicious actors. This is critical in digital age to protect data and privacy. And 7, compliance and regulation, such as healthcare and finance. Testing essential for compliance with industry-specific regulation and standard. Fail to comply can result in legal consequence. 8, testing is an ongoing process that leads to continued improvement. Feedback from testing can be used to refine and enhance product or process. In 9, cost saving. Detecting and addressing issues early in the development or manufacturing process is generally less expensive than fixing them after a product is released or in the hands of customer. 10, customer confidence. Trust. Testing can instill confidence in customer, knowing that a product has been rigorously tested can make customer more likely to purchase it and recommend it to others. 11, testing can help identify performance bottlenecks and areas for optimization, allowing for fine-tuning and improved efficiency. And last, decision support. Testing results provide valuable data that can inform decision making process. It can help business make informed choice about the release of product update and patch. In summary of this, testing is essential in various industries to ensure product quality, safety, and compliance, while also reducing risk, saving costs, and ultimately satisfying customer is a critical phase in product development and quality control process. And next, realize this the important thing that must be discussed in is thing to consistently be aware of regarding testing. 1, no universal software test process, no best practice. 2, show present defect. That mean on feature defect or bug or anything can be possible. Yeah. And 3, it has strip testing impossible. And today, we talking about automated tests according to my topic, automated tests on web map application with Cypress. I'm going to show you the automated test framework that I use to my work. Okay, let's show Cypress. Okay, Key benefits of Cypress is real-time reloading. Cypress offers a light reload feature that instantly update test result as you make change, speeding up the development and debugging process. Easy debugging. It provides an interactive and user-friendly debugging experience, making it simple to pinpoint and resolve issues. Robustness. Cypress is known for its stability and consistency, making it an excellent choice for continual integration and continual delivery pipeline or CI/CD. And this example for Doc Cypress, if you interest, you can open www.cypress.io to open Cypress Docker. You can search and view why Cypress. What is it? How installing Cypress? In first script, do you want to write test script and that show command that you want to write to test automate on your project? Okay, example. This is one of my work. There www.dragonfly.or.th that built by Dragonfly of Thailand. This web has all function about map. Sure that I write automate test by Cypress. In or function or element that have ID, and I can use this ID to write my automate test. I want to show some function. When we click to calculate area, when I click point 1, 2, 3, or any point which you want, and double click last point that show square area that you want. Okay, how can find ID on website? When we want to find ID, you can press F12 to show basic code on site on website, and you click the arrow and hover your cursor over this element and to see the ID the element. On Cypress, it's easy to find when running Cypress open from a script with the command side.visit and double code and input www that URL that you want, and select the button that resemble a circle shape. Click on the reserve function and its element ID will appear at the top bar. Yeah. Okay, however, if the ID displayed on the bar is not a user-defined ID from the programmer and the website has dynamically generated IDs, be caution when using for testing. Using such an ID may lead to misalignment, incorrect click, and worst of all, the fail to locate to that ID again. In such case, fail occurred instantly, even if there was no abnormal behavior. Due to teams work related to map both on web and mobile requirement map functional, I would like to share my current experience and my solutions in our present. Limitation of Cypress for mapping. In my use case, Cypress is quite responsive for website testing. However, it would be better if can test mobile apps like how I test website. Moreover, concerning web mapping, it had limited use case compared to other frameworks. I spent time trying to find a way to retrieve map IDs. I found a solution from user to see. Therefore, it's challenging to use Cypress extract map ID. I looked for a solution until I came up with this line of code. I use site get canvas and click x, y, and input FOSS2 and command second point, click point, and use db click in last point, and then can use in Cypress. Okay. This simple method that I want to share with those interested in using the drawing function on a map website. I hope that in the future I may discover a better and certainly more efficient way. In order to come across different methods, I would be happy to try incorporating them into my work. Feel free to share with me if you have any question or want to share something. I hope this session is helpful. Thank you for joining. Thank you.
Thank you very much for your presentation. Is there any questions from the audience? I should try and come up with a question for you because you give such a nice presentation. Yeah, testing is very important to the stability of our ecosystem. So thank you for sharing your work with us today. Any questions? Okay. Thank you very much for your talk.
Thank you.
How is everybody doing? Are people still warm? It's really nice to see so many people here this afternoon. Yesterday they were all huddled up together for warmth over at this end of the stage, so I'm really glad to see people spread out and feeling comfortable. You said? So up next, we have a project that uses one of my favorite technologies, Ruby. Ruby is a very cheerful language out of Japan, and I really adored learning Ruby when it first came out, and so I'm excited to hear about the use of Ruby and Ruby on Rails with Geo. So take it away.
Yeah, thank you. My name is Taro Matsuzawa from Geo Republic. So I introduced RGO today. So today's slide is available at online. So please check this URL. But if you the Safari may bugs in this QR code. So please be careful. So my work is Geo Republic Japan GIS engineer and sub-president Japan Unix Society and director both OSGeo Japan and OpenStreetMap Foundation Japan and lead of United Nations OpenGIS 7 Core. So my hobby is Script. So my skill is Ruby on Rails and Python and Postgres, PostGIS and JavaScript, TypeScript and Unix. Yes. So my community works is I'm a maintainer of tile.openstreetmap.jp. So this is a freedom, the free for use worldwide tile server for OpenStreetMap Japan community. But this tile server is enabled to access from worldwide. So, but location is in Japan. So please notice location. So, and the maintainer of Caritas on the Determine GTT and the contributor of type OL Open Layers EXT and Regex Persist, Persist and more. So today's main topic is Ruby language is very powerful and simple and friendly with geodata using RGO. And the second is RGO is friendly with Ruby on Rails and PostGIS. So today's topic is 3 topics. So let's start first topic, concept and data model of RGO. So RGO is geospatial data library for Ruby, and RGO provides a set of data classes for representing geospatial data, and RGO provides too many spatial analysis operations. So RGO implementation is separate two parts. So RGO is a peer library if GEOS is not available. So, and RGO is a Ruby wrapper of GEOS if GEOS is available. And RGO supports many geographic geospatial data formats, WKT, WKB, GeoJSON, and shapefile, and so on. And RGO supports Project 4 and support too many spatial analytics operations. So RGO requirements, so MRI Ruby 2.6.0 or later, and partial support for JRuby 9.0 or later, but highly recommend to use MRI Ruby and GEOS CAPI. So benchmark is peer Ruby implementation is slow, very very slow, and FFI implementation is slow than 2x. So please use CAPI is I recommend. And how to install so at the first install the GEOS libgeos dev and lib project file project for dev and project.data and install gem install RGO or insert the following line into your gem file gem RGO. So RGO has some extensions. So RGO GeoJSON is GeoJSON support format support, and RGO special shapefile is shapefiles format support, and RGO Project 4 is Project 4 support. So and Ruby on Rails support is RGO provides active record extensions for Ruby on Rails for with PostGIS. So and yeah, so the name is active record PostGIS adapter. So and MySQL and SpatialRite active record adapter is developmented, but there there is one is archived and one is maintenance, not maintenance. And RGO data model is RGO supports OGC simple features specification, and RGO provides set of data classes for representing geospatial data. Yeah, so yeah, coordinates, points, line storing, polygon, etc. So coordinate basis, coordinate is set of x or set of xy values. So it is a simple implementation. And the factories, the RGO implements a lot of factories that Cartesian, geographic and geographic projected and etc. And Cartesian factory is a default factory. So Cartesian factory is means this factory is set get the factory, and the factory dot point is create point, and implementation will be Geos CAPI factory if Geos is available. And if you want to use a Ruby implementation, you can use a simple factory. And so if you want to create suffixal factory, so you can use this factory, and but the result is maybe same as so. But if you want the 3D data, so you need to set as z coordinates true, and the point is 1, 2, 3. It's so 1 is x, and y is 2, and 3 z is 3. So yeah, so it is how to create 3D data. So and with m coordinate, so you need to have m coordinates true, and specify an SRID. So SRID is can set the factory and SRID options. So the factory use the SRID 4326 using Geos. So it's Tokyo Station's position. So I talked about the point is so point have the only coordinates, and you can use with the WKT. So factory dot pass WKT is generate the point data, and you can also line storing function to create set the points. So you can create line storing, and others supports line too many polygon and geometry collection as multi-point. Too many classes is supported. So basic manipulation and querying geospatial data. So in the geospatial analysis operation has two patterns: an array and binary predictives. Sorry. So contains so you can use contain, so my position, the data is contained if the contains this position. So put let's key is so official example, And the intersect, so you can use the line, the two line, get the two line and the JSON, and you can check the geometry, check the intersect on the geometry too, and the result is true. So another analysis operation is the too many functions. So I introduce distance. So this function is getting hotels data from my GeoJSON, and GeoJSON so returns the distance functions calculate all distance from Tokyo station point, and so mean by returns the mean values. So mean value may nearest, and max by may return farthest. So let's talk about integration with Ruby on Rails and real-world application example using RGO. Ruby on Rails support is RGO provides active record extensions for Ruby on Rails with PostGIS. It's provided by active record PostGIS adapter. Active record is powerful and simple to use, and RGO is friendly with active record. So overview is the actor access Ruby on Rails and if so you have the geodata with PostGIS. So PostGIS adapter active record PostGIS adapter to the access to the database, and then the result it's covered with RGO, and so you can get the geographic data. So yeah, let's create the application. So it's only 17 steps. So so Rails new API. So it's let's create API mode and the database to set PostgreSQL, and let's add the game file let's add active record PostGIS adapter to game files. So RGO and RGO GeoJSON and active record PostGIS adapter. So it's useful as a 3 line. So and the next database changes adapter to PostGIS, and then create database. So and next, let's create the migration file to enable PostGIS extension. So enable extension PostGIS is this migration file is enabled to PostGIS in your database. And create the model and migration and controller via scaffold. Scaffold is easy command to generate everything. So it generates the empty migration and model and controller to related name the toilet. So the Rails G scaffold toilet. Then create the toilet models. And so you need to change the following line. So you need to add the name and SC point, location, and geographic true. That means default is SRID 4326. And let's migrate. So yeah, then so your you can add you added the table of named the toilet. So next, download data from overpass part tab. So note amenity toilet and save export as GeoJSON. And let's create put the GeoJSON data to DB seed data directly, and then so edit seed RB. So seed RB reads every GeoJSON file and insert the into the toilets database to the name and location. And then run DB sheet. So import the old data and so print out the count is 662. And toilet edit the model of toilet RB. So as GeoJSON is a utility function to output GeoJSON, and as GeoJSON function is the override as this function, and the geometry is GeoJSON encode the self coordinate location, and the properties the except location the attributes. And next, application controller. So yeah, so toilet all is default, and but the GeoJSON is we need the feature collection. So and yeah, so let's change this function, create this function and render to GeoJSON. Then output the GeoJSON output. But extension is JSON. So let's support the GeoJSON output. So MIME types, create MIME types in initializer. So and this code only register the application vendor GeoJSON to GeoJSON extension. And the next fixed root RB. So and the resources storage, the default is format is GeoJSON. So output is so to be GeoJSON. Yeah, that's all. And so index HTML can access from the QGIS. Also, so you can define scope, and so it is a destination of so how destination with functions, and so set parameters the destination scope. So and so let's get you can get the query of the radius is 1,000. So near the toilet, you can get near the toilet. So to do is this application to do is so let's add some functions. So and so thank you. So that's all.
Thank you very much. That was great. Can I ask, how many people are involved in this project? Is it just you? Is there more than one developer?
I'm not. So I'm a user of Argio, and
Okay.
yeah, but sometimes I check the issues in GitHub. Yeah.
Okay. So how many contributors?
I forget, but yeah, I forget the contributors' names. So,
Okay.
Yeah.
Well, thank you very much for sharing this project with us. We appreciate it. I'm afraid we don't have time for questions, but thank you. People can buy you a beer at the gala tonight if they have questions.
yeah.
Thank you very much. Next up, we've got Brandon. I'm actually very interested to hear Brandon speak. At FOSS4G North America, they were promoting the idea of a cloud-native spatial data infrastructure, which is built in part on one of the innovations you've come up with, the PM tiles. So thank you very much for that work, which is serving to inspire everyone.
All right, awesome. Thanks, Jody, for the intro. And I'm going to talk a little bit about PM tiles, but also a lot more. So I'm Brandon. I'm the lead developer of a project called Protomaps, and I have a company behind that. But I'm going to sort of focus the talk on the theme of this specific conference, which is FOSS4G Asia, and talk kind of exclusively about Asian web map localization. It's a very specific thing, but I think it is a topic that impacts all the projects that are at this conference, and millions, maybe even billions of people. So why Asia? It's really a topic of geography, because if you, there's this sort of optimization problem, which is what is the circle in the world where you can fit a majority or more than 50% of the world population. And it turns out that multiple geographers have tried to do this calculation. This is someone on Reddit. And they found that essentially this circle that is centered around East and Southeast Asia is more than 50% of the world. So any open source project you do, especially anything that is related to maps that people use, if you're going to design it for the world, you better be prepared to deal with topics, features specific to Asia. And why this topic of web mapping? I took a little look. I'm not sure I totally believe these numbers about like mobile applications, but you can see even within East, Southeast, and South Asia, there's a huge variation in mobile devices. If you're building a solution for mobile phones, which are popular, do you build it for Android? Do you build it for iOS? Well, it turns out iOS isn't that popular in Korea or India, but is really popular in Taiwan and Japan. So the benefit of the web as a platform for doing geo or really any sort of technology is that it is more or less universal. These projects like WebKit, Blink, and Firefox, or the engine behind it, Gecko, have been developed for decades. They have great internationalization capabilities. They are truly universal in that you don't require an end user to download a desktop application to buy something through the App Store. You can provide a service, whether you're a company, whether you are in the public sector, through a web map, and that reaches as many people as possible, unlike native. And the Mozilla Docs, great, very reliable web resource, has a page on internationalization, or I-18N as it is shortened. And within this, they talk a lot about writing systems, which is, we might be using English for this conference, and it's the language I'm most comfortable using. But that isn't always going to be true for your entire audience. It makes sense that if you are building for, in the Korean public sector, then the application, the software should probably be in Korean. But for other countries or other places in the world, cities, they might have multiple languages. They might have both English and Chinese as official languages, like in Hong Kong. So this question of what is the language that we are delivering software in is really important to me. And where this influences FOSS4G is base maps. So a base map is almost going to be present in any single visual geographical application. It is the most basic commodity layer for all web GIS, for all applications, and the purpose really is to familiarize the end user. They should recognize that on a map, it should say Seoul. It should have Seoul in probably in Korean characters, maybe in Latin characters to help other people read it. Some of the big proprietary vendors of base maps are Apple, are Google, and Esri, and those do a pretty good job. They have, these huge commercial companies that produce these data products, but they're not the solution we're really looking for at this conference because these are not open source. And within the open source web base mapping ecosystem, there's sort of two major approaches right now. One of them people refer to as raster maps, which usually encompasses libraries like Leaflet, OpenLayers, rendering tech like Mapnik or GeoServer, or using a hosted vendor like OSM.org or a commercial company. And the alternative is to use what people call vector maps. They're delivered as vector tiles. As of now, these are mostly focused around a couple of open source client-side rendering libraries where the styling of the map is done in the web browser, usually something like Mapbox.gl or MapLibre.gl, which is a fork that we just had to talk about, as well as using vector tiles from any number of vendors. And these are like the main two open source web mapping approaches right now. But one sort of consequence of maps as oftentimes a commercial business is that even though 50% of the world lives inside the light circle, 50% of the business of maps is probably more like in the green circle. And a lot of the reason that the technology, especially in open source, is focused around usually English, maybe German, maybe French, maybe Western Europe, is simply because there's not a commercial use case, or we have not sort of developed the open source software to the point where it handles languages in Southeast Asia. That's not been a priority. So I think this is something that is a little bit of a call to action for this conference, which is how can we improve the open source ecosystem for 50% of the world. So what is ProtoMaps? This is the open source project I work on. As Jody talked about, it is consists of a few different parts, and at the core is something called PM Tiles. So PM Tiles is a cloud-native format for map tiles, and its goal is to make hosting a global map as easy as hosting HTML or CSS. So I think so oftentimes self-hosting a solution is kind of a dirty word because it can be complicated, but with ProtoMaps and PM Tiles, it's made to be as easy as simply copying a file to S3. And part two is what do you deliver in PM Tiles? Well, my project focuses on delivering a global base map as PM Tiles. It's derived from the best open source database, OpenStreetMap, as well as other data sources like Natural Earth. Here's what our base map looks like when it's focused on Korea. There is also an API you can use that's supported for commercial use by GitHub sponsors. And this build is open source. It is on GitHub, and it runs every single day, incorporating all of the changes to OpenStreetMap that day. So it is directly tied to OSM data. It is user editable just with OpenStreetMap data. So an example of how this works, let's say you are building a company or you are in city government for Seoul and you want to have an open source solution for the base map just for Seoul. Well, what you can do is there's a new feature called PM Tiles Extract using the command line interface that's open source. You can point it at the daily global build and you can ask for just a bounding box. So just this one rectangle region that contains all of Seoul. How this works internally is it is not going and scraping every single tile one by one because there happens to be thousands of tiles. It's going to take a while. It uses a Hilbert space filling curve design where internally the tiles are organized on a curve. So when you ask for just just Korea, then you're asking for only a couple of sort of contiguous ranges inside the file. So for demonstration, asking just for Seoul is about 35 megabytes, and 2,000 tiles takes 20 seconds to generate from the planet. You don't have to store, or like I don't store a separate copy of every single country. I just have one big planet file, and you can extract one city or one country. Like if I wanted to extract South Korea, I can ask for this bounding box, and it turns out that is about 600 megs, 250,000 tiles, but it takes less than 2 minutes to download just that Korea data. So where does this fit in? Like, why would you care about this? Why would you use it? There's plenty of other base map services, but usually those, they might be built from open source components, but there's no real way to replicate them. There's sort of a, some secret sauce, some complexity that's hidden behind an API. With metered use, they have a restrictive TOS on how you can use it. Can you cache it? Can you use it offline? You're locked into sort of this rent-based model where you are paying them rent to use their service, and where the data comes from or who controls it is a little bit opaque. So the purpose of Protomaps is to make open source the value proposition. All the core features are open source. You can reproduce it within government, within your company. You can combine your own data. It is clear where the data comes from. And ultimately, it allows you to have sovereignty over your maps. It is under your control. It's not going to be deprecated in a year. And I'm lucky to be supported on this project recently and in the near future by two foundations. One of them is Radiant Earth through the Cloud Native Geospatial Foundation, and the other one is NLNet, which is a European foundation for open source. And just going back to this topic of Asian mapping, there's people here that work in the public sector, and so this issue of what language is shown on the map is really important if you are providing government services. Here's an example of just from Wikimedia on all of the writing systems of the world, and you can see how they're sort of clustered in this 50% of the world that we're interested in. Just zooming in, a lot of these are languages that are used in South and Southeast Asia. And sort of one of the major obstacles to FOSS is that popular map rendering technology has no way or does not do a good job of showing these languages. Here's an example of the government of Nepal and the official map they published. So obviously, it is all in the official language. Yeah, it's all in Nepali. But if you try to download an open source web map, it'll often be in English because maybe the data has not been added to OpenStreetMap yet. There was another great talk yesterday about adding more Nepali names. For countries or territories that have multiple official languages like Hong Kong, well, you're going to have a switcher to move between Chinese and English. And all of this data often does exist in OpenStreetMap, but the default rendering of OSM is like the tip of the iceberg. If we look at Singapore, which has at least 4 official languages, all you see is the English or Latin Singapore label on the map. All of the tag data for much more than 4 languages is in OSM. But one of the limitations of raster-based rendering is you cannot do any client-side customization. So in terms of the 2 major tech stacks, what we're really is favorable for localization and for multilingual rendering is MapLibre and other vector-based solutions. One thing that I'm working on in 2024 is locale-specific logic. So if we wanted to do some processing of language tags for specific countries, if we wanted to make things like the formatting of punctuation correct for countries, this is a major feature I'm adding next year, which is doing a spatial join at tile creation time to use the right tags from OSM, because OSM as a raw product is not quite enough to build a correct multilingual map. And additional challenge areas beyond multi-language and multi-script, one of them that might be interesting to a Korean audience is CJK rendering, and then I'll talk a little bit about indic rendering. Two of the major challenges for both the raster and the vector map stacks, one of them is that in general, because in Chinese, Korean, and Japanese, the glyphs, the individual characters are much more detailed and fine than Latin, then it's often hard to read those characters using raster tiles. You might need to generate another set that is like high resolution tiles to be able to see things clearly. It's not really great for accessibility. If you have elderly users using the map, they might think the labels are too small. One of the major drawbacks of the Map Libre rendering stack was that it showed very blurry characters for Chinese, Japanese, and Korean. So this is actually a patch I just finished up last month, and it doubles the resolution of all Chinese, Japanese, and Korean characters in Map Libre. This was merged in Map Libre 3.4.1. So if you're using Map Libre anywhere in the Chinese, Japanese, or Korean speaking world, I'd highly recommend you upgrade. This is all released on NPM and should greatly improve the language rendering of your map. Talking a little bit about indic rendering. So these are all of the native scripts in South and Southeast Asia. In Nepal, it is the Map Libre text renderer technology cannot correctly render, so in this case it is Devanagari script, so you can kind of see this, this hook on top of this label is in the wrong place. So the software right now does not support this at all. It's also not supported by Mapbox GL. There has been a little bit of work in Map Libre in Map Libre native to support Khmer in Cambodia. This is limited only to Khmer for now. And there is a talk on the Map Libre site about how Grab implemented this. They use a text shaping engine, Harfbuzz, on Android. And one of the last challenges, especially challenging, is in Burma or Myanmar. This is the capital of Myanmar, and it is completely butchered, so Map Libre cannot render this at all. And not only that, there's a secondary problem of OSM as a data source does not always contain Unicode for Burmese. So Burma is one of the few countries in the world that is not 100% on Unicode. So in order to convert or detect the non-standard encoding of text, which is called Zagi, you need to use a classifier. So one of the things I'm working on is to build a classifier to correct non-Unicode text in OpenStreetMap. So Oliver, who is one of the developers behind Map Libre, has a really great quote in his text rendering guide that he wrote up, which I find inspiring. And it's that it is an exciting time to work on open source like Map Libre, because any improvement is going to affect millions, if not billions, of users that can enjoy maps in their language. And that brings me to the end of my talk. I hope you are inspired by this call to action to improve localization. Like I said, this is a global FOSS project, Protomaps, made possible by my commercial clients, sponsors, thank you, as well as foundations. I'm really happy to talk to anyone that is working on localization problems with maps. You can find me on LinkedIn, on Mastodon, and you can contact me. And yeah, just find me at the conference. Thanks.
Thank you. What an absolutely wonderful talk, and what a wonderful talk for this event. That's great. Are there any questions from the audience?
Any questions?
With, I'm curious, with the Indic languages, is it issues with multiple flow directions in the script?
Multiple flow directions is mainly an issue with Hebrew and Arabic, and those are solved via a plugin in MapLibre.
Okay.
The issue is what are called complex text layout or shaped languages, where the flow of code points is not simply from left to right. There is some context-specific positioning. And those are mainly found in South Asia. And the current font format, which is a custom font format specific to MapLibre, does not hold enough data for that in order to make that correct.
Okay. Yeah, I may have some follow-up because I know somebody who worked on it for Malayalam. So,
awesome.
Cheers.
Cool.
Anyone else? Okay. Thank you very much, Brandon.
Great, thank you.
Well, hello. I will join you on this side of the stage. I get to introduce myself. So, hi. Pleased to meet you. Yeah, so my name's Jody Garnett, and I'm going to be talking a little bit about a project I've been very privileged to work with, GeoServer. So GeoServer is one of the original OSGeo projects. Excellent. The slide advance works. So this presentation was put together by myself, Jody Garnett, and also Andrea Amy. Andrea works for GeoSolutions, which is one of the core contributors for the GeoServer project, based out of Italy. And I'd like to thank my employer, GeoCat, which is based in the Netherlands, for the opportunity to speak with you today. I'm from Canada, not from the Netherlands, but I get to work remotely. We are hiring. If anyone else would like to work remotely, I'd love to work with you. So a little bit of a background about GeoServer. GeoServer is a Java web application. Its goal is really to share your spatial information. So the idea is to take your data from any major data source and being able to publish it with open standards to share your data with a wide range of clients, web mapping, mobile, researchers, and so on. So our core protocols come from the Open Geospatial Consortium. These are standards like Web Map Server, Web Feature Server, Web Coverage Server, and so on. And then we have additional extensions which you can install. They're optional for things like Web Processing Service, and then also some of the newer OGC API standards such as OGC API features and OGC stack. So the idea with GeoServer is you publish your data once, and we speak as many protocols as we can to get your data in the hands of the public. So just a little bit of an update about the GeoServer team. We're managed by the core project steering committee, which is brought together from a bunch of different companies. But more importantly, not all of these people are developers. It's really nice to have Yuka, who's a power user, on our steering committee. And we like to try and have a balanced team of developers and users in order to better represent our community. We also have a number of service providers, so these represent our employers. GeoSolutions and my employer, GeoCat, were core contributors that take on kind of all the maintenance activities and make the releases for GeoServer each month. We also have experienced providers, so these are people that have a history of contributing and supporting the project. In terms of our infrastructure, GeoServer has been developed in public since 2001. So we've always had our source code available to the public, and right now most of our infrastructure is hosted by the Open Source Geospatial Foundation. And in the last year, we've started publishing Docker images. One of the people in the audience was going to help me get that on Docker Hub later today, so thanks for that. We're looking forward to that contribution. Sorry. We also have community modules, which is how we do research and development. So for GeoServer releases, we always have a rule of two. So we always have a stable release and a maintenance release. And the idea is that you should update GeoServer once a year to a stable release, in which case it'll get 6 months of updates and then further 6 months of just kind of important security patches and so on. So we are just released GeoServer 2.24 earlier this quarter, and that's the one we recommend you use at the moment. If you are using an older version, please update. That's the only way we can reliably get, the only way we can reliably get security updates to you. Okay. As I go through this slide, if you read at the bottom of the screen, you can see the author of any given change. You can see the version number of when that feature is available. And then importantly, you can see the person who paid for it. So we really like to thank our customers and our sponsors of functionality. Occasionally we do things out of the generosity of our heart. So if you see a little heart symbol, it's something a developer has done to make them happy. And then some of the things are community modules. So they don't have a version number. They're not released yet. They're being shared as an experiment in the hopes of attracting other people to take part or contribute financially so the functionality can show up in a future release. So the big change we did in the last 6 months is absolutely not exciting at all. So the GeoTools library is the engine that sits underneath GeoServer and does a lot of the heavy lifting for data formats and drawing maps and all that kind of stuff. And the GeoTools library had a major refactor that was done with some funding from the Open Source Geospatial Foundation, and that was done at the bequest of the Apache Foundation. So they wanted us to change one of our packages from org OpenGIS, which is trademarked, to org GeoTools API. So almost half of the GeoTools codebase changed, and about a quarter of the GeoServer codebase changed. So this was a major activity. I think we raised, or we got about $15,000 worth of funding in order to make this change. This change was done at the Bolsena Code Sprint in Italy, and we had a wonderful time. We worked really, really hard, enjoyed some nice food, and we were successful in making this change and releasing GeoServer in October. So yeah, we were very happy to get this work done and really thankful for OSGeo for funding the activity. In terms of the distribution, I already kind of spoiled this surprise. We do now have Docker images available, and so this is a new distribution for us. Traditionally, we've only done binary and web application downloads. In terms of mapping, one thing that is always going on, mostly done by GeoSolutions, is the USGS has funded some improvements to improve image mosaicing performance. So this is really important for organizations that have large, vast quantities of raster data. So always nice to see improvements here. Another interesting one, which I'm very impressed with, is improved hyperspectral performance. So I usually work with imagery that is just red, green, and blue bands. Hyperspectral is for raster data that has hundreds of bands, and it's very impressive that the GeoServer image processing engine is able to work with this data and dynamically stream it on demand. And it's nice to see performance improvements here also. I'm not sure what DLR stands for, but very much thank them for funding this work. Another interesting one is raster attribute table support. So this is functionality that you might be familiar with from QGIS. So this is where different values in your raster are assigned attributes or are categorized, and this allows GeoServer to read the same attribute table that is handled by QGIS so that we can publish up raster information. Okay. Next up, we've got some data source updates. So this is an interesting one. This is actually some functionality that used to exist in GeoServer 1, where you could adjust the attributes and control whether they were nillable or not. And it made a reappearance in GeoTools or GeoServer 2 very recently. And what this allows you to do is this allows you to customize the attributes that GeoServer is publishing. You can rename them. You can give them a description, a human readable description. And then you can also generate attributes on the fly using small expressions. So this is a really powerful feature for GeoServer. And the improvement for GeoServer 223 is we can now provide that human readable name. In the future, I would love to see this support internationalization, so the attributes can be displayed in different languages. A community module is cloud optimized GeoTIFF. So this is the idea of storing your GeoTIFF on very cheap cloud storage in a format that can be streamed into GeoServer. And so GeoServer can use cheap cloud storage in order to store the raster information that it's sharing with the public. Okay, so the improvements here are being able to store cloud-optimized GeoTIFF on more service providers, S3, Azure, Google Storage, and so on. Another kind of interesting one is the STAC, the Spatial Temporal Asset Catalog. This is a catalog service that provides an index of where all your cloud-optimized GeoTIFFs are. And what's interesting here is using GeoServer as a front end that talks to a STAC catalog on the back end and pulls in all the raster data for an area in order to display it. So this represents a really exciting bridge between the newer OGC API STAC catalog service and GeoServer, which is able to integrate with so many other systems using the OGC open web services. Another one in the same area is a vector mosaic store. So this allows GeoServer to make use of vector tileset as a feature source in order to draw the feature content. So it's really nice to see these integrations between GeoServer and other web services. It provides a lot of flexibility for the project. This is also a nice one for me. So this is a contributor who's been very productive in the last year. Roar Braden has gone through and done a lot of quality assurance and checking, and he's actually managed to close 50 tickets in the last year. So I just want to say thank you to him for the excellent work. And here's another very impressive bit of work. So up until very recently, PostGIS and Shapefile have been some of the fastest ways to store feature content. This developer, Bjorn, has actually made improvements to the flat GeoBuff data format, and this is a cloud-native single file format. And he's done so many optimizations that this now represents one of the fastest ways for GeoServer to draw things. So I know that this looks kind of very much like some kind of painting done by Van Gogh, but every one of these little things you see here is information coming out of a tractor that is doing precision farming. And so it's a hugely detailed data set. So a few million polygons are being drawn as this tractor goes around a field doing its crop work. So very impressive, really impressive performance. On the services front, some work that I did as part of that GeoTools refactoring was I managed to gather up a bunch of GS printing modules. So this is the module that's responsible for publishing PDF output for people to print. So I managed to gather up various forks that different organizations had done and update them all to Java 11 and update the code for GeoServer. Oh, I'm sorry, there's a pop-up in a language I can't read. So one benefit of this is that the GeoNode project has traditionally used a fork of GeoServer so that they could get the printing functionality that they desired. With this improvement that we were able to do, GeoNode can now just use GeoServer out of the box, which will be a really good relief to that community. I really wish they'd stepped up and volunteered or funded doing this work earlier, because they maintained a fork for a number of years, which is a little bit frustrating for their community. One service I mentioned earlier was the new OGC API community module. This module is still steadily under development. We are currently in a little bit of a holding pattern, waiting for these standards to be finalized by the OGC. We'd like to thank GeoNovum for funding some impressive work on these standards. And so the core OGC API features API now passes site tests. We're still waiting for the filter, the ability to query this API to be standardized. But yeah, look, it's really great to see progress here. A change for configuration and setup. A couple years ago, I redid the GeoServer welcome page so that it shows the different web services that are being published as little boxes and allows you to change between different workspaces. I really enjoyed this change, and my customers really enjoyed this change, but some customers that have tens of thousands of layers really were unhappy because this was slow. So a configuration change has happened, allowing them to turn this off or allowing it to detect if someone has too many layers or it's too slow to respond. It'll default to just a very simple display. So it's nice to see these improvements adapted for larger GeoServers. An interesting change, this is a community module, is set up for groups that use one GeoServer in a multi-tenancy arrangement. So one GeoServer to support lots of different groups, and that allows them to, based on the subdomain that the GeoServer is being accessed from, to change what workspace is being published. And here's an interesting one, taking your GeoServer beyond the confines of Earth. So GeoServer fundamentally has always used the EPSG coordinate reference systems, and this change adds the addition of the IAU standards, which is the one used for different planets like the Moon and Mars and so on. So in GeoServer 224, you can now start to share a map of the Moon or start to share a map of Mars. So here's what this looks like. You can actually define a Mars North Polar projection. I don't know how many people have these data sets, but it's really fun to see, and this was funded by the USGS. Previously, people would kind of fake this with ESPG codes, which means they could kind of get it to work, they could get a visual, but no client like QGIS or anything could understand what was going on. It was just kind of one-off experiments. So it's really nice to see standards used so that this data can be enjoyed. All right. I now have something a little bit less exciting to talk about, which is security vulnerabilities. Now, I've been warned not to talk about security vulnerabilities too much, or people start to get worried and concerned. But what I do want to do is share some of the improvements that we've been making to the GeoServer procedures and communication. So GeoServer is no more vulnerable today than it was last year, but we are trying to do a better job of communicating, because normally all I do is each year I say, please update your GeoServer. It's the only way I can help keep you secure. But what we've changed this year is we've started to issue these CVE numbers, the common vulnerability and exploit numbers. And we're just doing that as another tool to communicate to you to remind you to please update. But it will mean that your security department will do a scan and say, oh, you've got an old version of GeoServer, and start yelling at you. That's great. They're probably much better at yelling at you than I am. So we also had an awkward situation where there was this CVE published for something that we'd actually patched and fixed a couple years ago. But it did come under active exploit in about February of this year. So older GeoServers started to be attacked and compromised. So even though this was patched, Many people hadn't noticed and updated their systems, and hackers started to take advantage. So this was one of the motivations for me to start to use CVE numbers to communicate. So this problem's been fixed since GeoServer 2.18. So it's been fixed for a number of years, but many organizations hadn't updated yet. So the change that we made was a change to our disclosure policy. So our policy is still the same. We wait until we've patched the releases of GeoServer that are available to download, and then we tell people, hey, there's this security vulnerability, but you've always had a chance to update your GeoServer first. We used to call this responsible disclosure, but the security researchers told us that the new cool way to say this is coordinate vulnerability disclosure. So that's what we do now, but it's the same procedure for us. Yeah, so we are gonna just, we're gonna be assigning CVE numbers to the vulnerabilities going ahead. And I probably talked too much about this, so people are worried. Sorry about that. One of the first CVEs we had the pleasure of sharing with everybody is a fix for kind of a fundamental limitation of web processing service and web map service. So both of these services let you make use of a URL to provide a style for drawing. And we want to be able to check and make sure that you trust that URL. Otherwise, people could use GeoServer to do a server-side request forgery. So there's a new setting, URL checks. It's on by default. And yeah, it's really nice to address this issue. It's been known to us for some time because it's part of the OGC standards. Okay. One thing that just comes up in vulnerability scans is an H2 database. It's not used very much by GeoServer, and we're phasing it out rather than fixing this problem. I'm going to wrap things up here. So I just wanted to thank two contributors that have been very helpful in the last year. Gabriel Rowland made some releases from camp to camp, and Peter Smith from Africa GIS has been really nice, and he's stepped up and he's made several releases for the community, and he's also improved the release procedure instructions. So it's really nice to see our core contributors maintaining the project, but we really appreciate new people helping out. We do try to recognize our core contributors on our website, GeoSolutions, Austin Technologies, GeoCat, but we also like to recognize sponsors. But there's a problem. We haven't had any. So the two sponsors that we've got here, one of them is North Road Geographics, and they gave us a small little thank you for speaking at a conference, and so we listed them as a sponsor. And the other sponsor, How to Map, is actually me, and I only sponsored so I would have little screen snaps to show people how to sponsor. So for such a successful project, GeoServer's only gotten about $1,000 of sponsorship in the last year, and one of them was just me doing an example. So we really would appreciate your financial support. It allows us to take on bigger activities. And we do have some bigger activities ahead. So I'm going to be converting the documentation from RST to Sphinx, and my company's employer, GeoCat's going to be helping do that. The other one is, in order to stay on a supported version of Java, we need to migrate from Java 11 to Java 17 in the next year. And that is going to take a little bit of work. The first phase, we need to update our image processing engine and update our UI to use Wicket 9. And in the second phase, we need to update some of the Spring framework that we are using, especially the Spring Security version 5.8 something, and get GeoServer working on Java 17. And we need to do that by October of next year, when Java 11 stops being supported. And the last one is, we need to change from Spring 5 to Spring 6 by December of next year. And that's a little bit more of an exciting change because we need to update to something called Jakarta Enterprise Edition and so on. So if I look at these slides, we have a number of components that GeoServer uses to update in 2024. So we don't currently have funding for this activity, but this is just an example of the roadmap planning that we in the steering committee look ahead to the next year. Okay, thank you guys very much. And thank you for offering me water, I appreciate that. Is there any questions? I can stand here awkwardly and then kick myself off the stage. I can invite the next presenter to start coming up.
Hi, I do have a question.
Okay.
If I can. There is also GeoServer Cloud, which is going on. So
yes.
can you give me, can you give us the idea about what it is and
Sure.
where exactly are we?
Yeah, so GeoServer, I think it's called Cloud Native GeoServer, and that's a project done by Gabriel. Remember the person who did a release in the last year? So he has I want to say a distribution of GeoServer, where he's taken all the components of GeoServer, and rather than update it to Jakarta like I just showed, he's updated them to something called Spring Boot, and made them into little microservices. And so it's something that's available on the GeoServer GitHub that you can try out. So it's the GeoServer application broken up into little microservices, and then you would use, sorry, I'm not very good at these technologies. Yeah, you would use the different cloud infrastructures in order to make a little constellation of Docker images. The idea, though, is to set GeoServer components up so that they can auto-scale.
But it's still under community, right? It's not stable yet, or?
It's not stable yet, but people, the camp-to-camp customers are using it in production. It's certainly something worth checking out.
Okay. Thank you.
Yeah, that's a great question. Any other questions? There's lots of development going on, so I might not be able to answer everything.
If anybody has to reach out for any of the support regarding GeoServer, the community, where exactly can we reach out?
So on our GeoServer website, under commercial support, there's a number of commercial support providers. I tend to like to direct people towards the core contributors, like my employer, but also the experienced providers that have a history of contributing to the project. But I also really like it when people can talk to the service providers that are in their local area. It really helps if you can meet with someone in person, and it's really nice if you can invest in your local economy. So if you go to the GeoServer website, there's the service providers that have approached the project and asked to be listed. If you go to the OSGeo website, you can also see service providers around the world that offer GeoServer support. And then we do have a bunch of community support options. So a user list, we've got a little, I want to say, Gitter channel that is occasionally active with developers. And then Ian Turton, which is one of the steering committee members, he also keeps a lookout on Stack Exchange or GIS Stack Exchange or something, and occasionally answers questions. Does that help?
Yeah, I was looking more for something like a Slack channel or a Discord channel, but you said like there is a Gitter channel for.
There is a Gitter channel, but realistically, folks are very, very busy, and we tend to drop into that channel when we're making a release and so on.
Okay, thanks.
And if anybody is a service provider, please reach out to me. I'd love to list you on the GeoServer website or help you list yourself on the OSGeo website. Having access to commercial support providers is very important for the growth of our community. All right, thank you. All right, I'd like to thank Jody Garnett for that excellent presentation and answering questions. That's really well done. So next up, we've got an update from one of my favorite projects, the zoo project, which isn't really made up of a bunch of animals. But the zoo project I am really proud of the zoo project. After a very long process of going through OSGeo incubation, it graduated earlier this year and is now an official OSGeo project, which is a major milestone. And I'd like to thank the zoo project team for working towards that. And I'm very pleased with your success.
Thank you very much.
And if that was part of what you wanted to share in your presentation, I'm sorry.
Okay. So, hi everybody, I'm Gérald Fenoy, CEO of the Geolabs company in France since 17 years now. I am here today to present to you the Zoo project, probably one of the most innovative open source projects for the last 10 years I have met. I have prepared the presentation with Nicolas Bozan, Venkatesh Raghavan and Rajat Shinde, with whom we have created the idea of the Zoo project. So, a brief introduction of the Zoo project. We are an open source project with multiple components that I will show you. We are mainly focused on the Open Geospatial Consortium standards and specification and draft specification, as I will show you later on. We started by implementing the OGC WPS, first version, which born in 2007, if I recall properly, and we started the project in 2009. So here is a short history of our work. So the idea born in 2008 in South Africa for the FOSS4G, organized by Tim Sutton at that time. Then we got the first talk in Sydney, FOSS4G 2009. And then every year before the FOSS4G, we were trying to make a new release to provide the announcement and make a release for the latest development we've made. And this year, as Jodie's mentioned, we finally become an OSGeo project. So here is a PSC list. So you can see the usual faces like Venkatesh Raghavan, Nicolas, and I. But we also have Rajat and Angelos Tsotsos, which is accessorily also the OSGeo president. And lately, we got Fabrice Brito from Terradue, an Italian company, which this Terradue company is using the Zoo project for many years, and they have announced it. I will talk later on about this. So we integrated him inside the PSC. Also, here is a list of the main developers that are involved in the Zoo project. This list is not exhaustive, but it's just proving that we are an international group of people working. So here is a traditional get involved slide where you can find the link to the mailing list, to the IRC channel, even if it's maybe obsolete nowadays. You have the bug tracking, everything is available on GitHub. You have the service provider which are listed in our documentation. You can contribute code, you can contribute application, you can contribute common workflow language application packages, you can also contribute doc or simply translation. So let's go in deep details about what is the Zoo project. So we have 4 main components. The first is the Zoo kernel, which is a generating processing engine, which I will focus on during the next slides. Then we have the Zoo services, which are, let's say, nowadays, as we speak about OGC API processes, we cannot say more services, but probably processes. So it's a list of available processes that are available when you're deploying the Zoo project. Then we have the Zoo API, which is a JavaScript API which can run on the server side, meaning that you can create complex application based on existing services and chaining them all together by using the JavaScript language. At the end, the last to come was the WPS Zoo client, the WPS client, which is a JavaScript library that you can embed in your web application to be able to communicate simply with your backend processing engine. The Zoo kernel, so it's an implementation of WPS 1.0 version, WPS 2, and also OGC API processes part 1 core. So the Zoo kernel has been implemented in C and C++, because C and C++ is the base of every single programming languages. This is the reason why we are able to support C, C++, Fortran, Java, PHP, Perl, Ruby, Python, C#, JavaScript, and R. It means that if you know only one of these single language, you can program your whole process, your implementation, only using these languages. Lately, because it is nice to support multiple programming languages, but it also means that you have to work to develop your new processes. So what we think was we should have to find a way to automate the integration of new services, and one way was to reuse the existing software such as Saga GIS and Orfeo Toolbox, and have their application available as WPS service or OGC API processes. Also, accessorily, since 2010, we were thinking that it would be nice for a developer to be able to automatically publish the result of an execution of a process as a web resource service. So let's say as a WMS and WFS in case your result is a vector dataset, or as a WCS and WMS in case your result is a raster dataset. So actually this is a great example because we've run once the process, then we have the result which is shown on the map for the safest path. Then we can use the same endpoint to request the WFS to have the details of this path, and then we can reuse this WFS as an input as it has been produced on the server side. It can be accessed fast also, so we can reuse this WFS request to have the profile, the elevation profile of this path. Since the beginning of, even if WPS1, even if it was not specified in the standard, we still got the get status service as a service, meaning that you were able to follow during the execution of your process the progress of your running process. So we've been involved in a European project named GeoSud, in which we modify the implementation of the Zoo kernel and create a new support, which is the HPC support, meaning that you were able, and you are still able, to execute Orfeo Toolbox applications that were running on HPC using Slurm and relying simply on a SSH protocol to connect to this HPC and invoke the execution of HPC task. And then we get back the information by email and so on. I will come back later on this because we've reworked on the HPC support this year and the past 2 years. So OGC API processes is a new version of what was called WPS. So actually it is almost the same thing except that it's an open API. So rather than speaking in XML, you can now speak in JSON only. So actually, you also have the capability to support both JSON or HTML. So we made a small demonstration of what we call the basic HTML user interface, which is available out of the box when you deploy your Zoo project locally on a server. And on the left-hand side, you have the Open API, which can be simple or complex depending on the purpose of the Open API you are deploying. For instance, 2 weeks back, I was in Vienna at the BITS event organized by the European Space Agency, where I was presenting, rather than using a Jupyter notebook, I was using Open API and MD file to describe all the steps from the workshop. Meaning that you can also do some example, include some examples, requests, stuff like that. So it looks like a Jupyter notebook at the end. Last year in 2022, we participated in the OGC OSGeo Apache Software Foundation Code Sprint, and we integrated the Map Server 8 support. Not by pleasure, but simply because it was supporting also OGC API features. So it means that if your service is outputting a vector dataset, you can access it rather than WFS as we were able to do earlier. You actually using the exact same code, you can now access the OGC API feature. This is a new way we are using the Zoo kernel nowadays because we have moved to the cloud and we get funded in the FIDIAS project, still to execute tasks on HPC server during the past 2 years. We have now multiple components within the Zoo kernel. So you have a frontal Zoo kernel, and then you have what we call the Zoo Fast Process Manager. So when the Zoo kernel receives a request that it should run asynchronously, it will send a message on RabbitMQ, and then the Zoo FPN will take the responsibility to effectively execute the process. We would like to thank the Microsoft company for funding the project and providing infrastructure. So they get $10,000 US last year, and we got $10,000 US this year too. So we are really thankful to Microsoft for their help. This year also in March, or February and March, we were working with the OGC for being certified. And the Zoo project is actually a reference implementation, as you can see on this screen, for both WPS2 and OGC API processes. So this is the new stuff we are working on for 2 years with the European Space Agency and a group and a bunch of companies. So the idea is that they have implemented what they called ADES, Application Deployment and Execution Service. I don't know if you are familiar with the OGC best practice for application package or common workflow language. But common workflow language is a meta language which can be used to define any kind of application. You have a link to a Docker image, which can be simply a Python Docker image. And then using the Zoo project, you will be able to deploy this CWL as a new process, which will be available on your cluster, on your Kubernetes cluster, and that can be run on the Kubernetes cluster. As defined in the OGC best practice for application packages, the input for such a process execution will be a stack catalog, and the output, which means the result of your execution, will also be a stack catalog. So actually, the implementation which is currently available is run on a Kubernetes cluster using the Kylrician runner, which is a CWL runner, which is able to run it on Kubernetes. And we are currently working with another company which will make us able to also run CWL application packages in Kubernetes cluster and or on HPC. So these are the development we've made this year. So we have updated the OGC API processes part 2 deploy, replace, and undeploy draft specification. And we expect to release it before the end of December, so before the end of this year. We have also integrated the support of our OGC API processes part 2 deploy, replace, and undeploy draft specification to be supported under the code name Zoo Project DRU. You will come back later on this. Then we have reused this part 2 deploy, replace, and undeploy draft specification for being able also to modify a bit the HPC implementation we had before, for being able this time to not only run processes on HPC, but also deploy Singularity container on HPC server. And then obviously using part 1 core, OGC API part 1 core to execute them on the HPC server. Also, during our year, we investigate and we made some research, and we have made some kind of new package which we will name Zoo EO API, where we are mixing data using the EO API platform, so the stack catalog and everything, with the Zoo project. Actually, you have only one endpoint, which is the Zoo project itself, where you can access your stack catalog or your tiles or everything using a single endpoint. So for the future task, we are willing to investigate the part 3 of OGC API processes, which is the workflow. For this workflow, we currently have already partial implementation, meaning that you can already chain processes together, even if it's kind of limited, at least the way it has been implemented. We are also willing to enhance and have a more efficient support for cloud native format. And actually, why we are pointing this out is because in part 3, you have the concept of collection input and collection output, which is very near to the stack catalog I was mentioning earlier, but still we are willing to be conform with this new standard draft specification. So here is the zoo services, so I will pass through them. We started initially by implementing all the GEDAL applications that you are usually using from the command line, and we made them available on the web using the WPS at that time. So we are not mixing metadata and source code. We are having one configuration file, the zoo configuration file, or your YML file, or a PG database, PostgreSQL database for storing the metadata, meaning what are the input, what are the formats supported for the input, for the output, and so on. And then you have the source code. So the source code, just to show you how simple it can be. For one input which is named A, and you want simply to print an hello world message, you can simply use, using the Python language, you will have dictionaries of inputs and pre-filled dictionary of output, and you only have to feed your output result with the value you are willing to get back to your client. Keys, this keys is just to mention, keep it simple, stupid. So these are the services we got. I already talked about Orfeo Toolbox and Saga.js. Then we have the Zoo API, which help you to chain services together, but also add logic in between the services execution. Here are a few examples of what we did using this implementation. Actually, we have built up on top of the Zoo project what we call MapMint, which is a SDI which lets you create your maps and publish them. So this was an old screenshot more than 14 years ago. It was about MapMint 1. So then we have the Zoo client, which is a JavaScript library to interact with WPS application. Here are a few examples that are the demos that are available online. So here you have the Saga demonstration, which is nice here, is that the formula to execute your process are dynamically created using the process description. Meaning that you can then integrate all these processes or application in any other web map application, which is just demonstrated here. So we have, this is a MapMint 2 version, which is almost the same modules that I was showing earlier. Oh, then during the last 4 years, 4 years back, sorry, the project has moved to GitHub, okay, everybody did that. We are also producing Docker images. For every single commit you do on the Zoo project GitHub repository, we are running the old test suite that we have written in 2012. And nowadays we are also running the official OpenGeospatial engineering test suite directly from our GitHub action. It means that for every modification also handled by the OpenGeospatial consortium in the ETS, it will be taken into account. We build the ETS from the GitHub action, and we run it through our current implementation. So you can find us on Docker Hub. We want to thank also Docker Hub for giving us open source support, meaning that we can build and we have no limitation to use the Docker Hub. So please go there and type Zoo project in the search box. Then you can also run the Zoo project on a Kubernetes cluster. So you remember I was showing you the Zoo project DRU, deploy, replace, and undeploy support. So you have the Helm chart to deploy it on your Kubernetes cluster easily. You can see that we got the certification and the official package stamp. And you have also the Zoo project HPGC, which is related to the HPC support I was mentioning earlier, where you can deploy Singularity container on HPC. So then, as I told you, we have built on top of the Zoo project this MapMint software. And this is it for me. I thank you for listening. And sorry for being quite long, but actually my slide is not reflecting all the work we are doing in this project. Thank you very much.
Thank you. And I'll invite members of the audience to ask a question. And I'm glad everyone's staying warm. I can't see from the bright lights. Does anyone have a question? Okay. Well, thank you very much. And where can people find you after this if they'd like to catch up?
Probably walking around in a smoking area or in the room.
So they could join you for a smoke or at the gala this evening?
Or I should be nearby the eating machine.
Okay,
You can find
sounds
me
good.
nearby your eating machine, yeah.
Okay. Thank you very much. And
Thank you.
I believe this concludes our afternoon session. So thank you everybody for staying with us this afternoon, and we'll see you later. Thanks.
It's time to start Digital Twin special session. First of all, thank you very much for your coming to the Digital Twin special session. My name is Sang Shin, and I'm a chairperson of this special session. Today we have 6 great speakers. One is from Australia, one is from Japan, and one is from United Nations, and 3 are from South Korea. So some of the talks will be in Korean, and the others are in English. But don't worry about that. Actually, we provide the simultaneous interpreter. So you can find the interpreter devices on top of your chair. So please set the channel 2 for your English, and please set channel 1 for your Korean. Actually, the first speaker is Anna Belgun. Actually, she is working for the CSIRO in Australia. However, unfortunately, she was not able to make it to Seoul. However, she sent the pre-recorded her version to me, so we can meet her through the movie. So would you please play the Anna's talk, please? Please welcome Anna.
Hi, my name is Anna Belgun, Product Manager and TERIA Group Lead in DA61. This presentation has been drafted in collaboration with Dr. Marie Trulove, Head of Product Management in CSIRO DA61. But firstly, some introductions of our team. TERIA team is part of engineering and design in CSIRO, the Australian National Science Agency. TERIA is a group of product managers, designers, and engineers. Together, they created TERIA.js, an open-source software library used in many applications for government, research, and industry sectors. This presentation is a collection of insights from the TERIA team's experience working on spatial digital twin programs in Australia. Full acknowledgement and thanks go to the teams at New South Wales Department of Customer Services, Victorian Department of Transport and Planning, and Queensland Department of Resources, who have supported the development of this collection about our shared digital twin journeys. The presentation includes lessons learned from the following topics: program genesis, policy development, communications, branding, positioning, and stakeholders. Continuing with programs maturity, use cases, data insights, and technology stack. But let's start with the foundations of TERIA's work in this space. The Australian government launched its open data policy in 2014-15, which mandated public organizations to make data available openly. That triggered the need for accessible platforms and technology to make that possible. TERIA.js started as a result of that need, and it was used to build numerous government applications using open data and open source software. In 2018, the use cases evolved to supporting a technology step change from 2D to 3D foundational spatial datasets and their use cases. Hence, we worked with governments to experiment and launch a number of initiatives, such as the New South Wales Spatial Digital Twin Visualization Service in 2018, Queensland Spatial Digital Twin Prototype in 2019-2020, and Digital Twin Victoria platform in 2021. The technology-based initiatives were contextualized in a number of guides and collaborations with government organizations to draft digital twin principles. Understanding now the context in which TERIA has been developed, let's turn our attention to the genesis of different programs across the country. All programs have evolved from a more modest proof of concept or prototype focused on a small geographic area of significant importance. They prioritize a catalog of datasets relevant to key use cases. They were focused on visualization, and they started with prototyping to understand the challenges before moving into drafting policies. Here are some examples of such programs focused on particular areas in Australian states and initiatives such as Brisbane Olympics in 2032. It was observed that infrastructure strategies were key in all digital twin programs across the country, thanks to their potential for reducing risk and cost blowouts. Having now an understanding of the genesis of various programs across the country, let's turn our attention to the challenges in communicating those to a larger audience. In the formative stages, each program carefully considered alternative branding to digital twin. They all had to respond to commentary such as "that's not a real digital twin," "that's a zombie twin," etc. Therefore, the content developed to respond to these questions and comments have included maturity models like this example. from ANZLIC, which stands for the Australian New Zealand Land Information Council, published in 2019. In terms of positioning and differentiation, taking the Digital Twin Victoria program as an example, a digital twin is seen as an ecosystem, not the only digital twin, and not all use cases will be applied in a single digital twin. Teria was a platform part of the foundational digital twin in this context. In other cases, some programs included the word spatial to differentiate from single asset digital twins. For example, like in this definition of digital twins released by ANZLIC, which states that a spatially enabled digital twin combines a digital twin with spatial and positioning information, covering a defined geographic space above and below ground. Unlike other programs, the Digital Twins initiatives across the country started from the ground up, focusing on collaboration between different stakeholders, focused on data, use cases, policy initiatives, capability, and platforms. Moving towards a more mature phase, some programs like Digital Twin Victoria, for example, became more clear about the groups of use cases supported by those platforms. In parallel, they recognized the need for foundational 3D datasets that would support the majority of use cases. And let's now move on to discuss some of those use cases, and we will show a couple of categories. This example, for example, illustrates the connection established between different digital twins in the ecosystem. It shows outputs from the eComply urban tool developed by an automated approvals workstream system. Other examples showing connections to other platforms include transport modeling, flood modeling, building management systems, structural health monitoring for bridges or other infrastructure assets. This example demonstrates enabling access to 3D tooling on the web without specialized systems for use in urban planning or specialized training. And let's now see the key learning on the use of data in digital twins. By definition, a spatial digital twin brings together future foundations, geospatial data, such as 3D and 4D, building information models, and real-time information from sensors and IoT devices. But despite the wide remit, there are a handful of key datasets that are common to all programs in the early stages. And here is an illustration of those. Let's analyze each of those types of data. The most common one is, of course, the geospatial information. Buildings and 3D imagery are probably the two most important first foundation datasets to provide a rich 3D context in a digital twin and support many use cases. Buildings have many options like level of details, textures, attributes, adding complexity to the requirements. Still, focusing on the geospatial datasets, we notice that utilities are a high priority on all programs. They all have experienced the requirement to develop higher resolution DEMS, like digital elevation models, to better define and visualize the transition of above and below ground data. In terms of byproduct datasets, experimentation with new approaches such as machine learning and the use of LiDAR to source height attributes has featured in programs to uplift data production and maintenance capability. In terms of building information systems, supporting BIMs in the digital twin is essential. It requires deep collaboration across government with BIM data custodians such as transport, health, education, and utilities. The data is never open, and it requires the development of new data technology and digital infrastructure such as conversion pipelines from proprietary formats to IFC and from IFC into open formats like 3D tiles and I3S. New data technology and digital infrastructure such as conversion pipelines from proprietary formats to IFC and from IFC into open formats like 3D tiles and I3S. With real-time data, although a key component of digital twin, the journey is still at a early stage with sensors and IoT. Maturing and scaling are possible through leveraging a connection with dedicated IoT platforms such as OpenDataSoft or public transport ones. If we think back at the fact that there is not one digital twin to rule them all, the connections between different platforms in the ecosystem has been made possible through DAA Federation. Federation of data and entire catalogs is now happening in Australia between jurisdictional platforms, both curating national catalogs into state digital twins and between state platforms. In terms of data governance, significant effort was made to develop data sharing agreements with partners and stakeholders across government, not just with data custodians to supply and publish data, but data custodians who want to also use the platform. And agreements are essential for platforms to support open, shared, and closed data. The development of digital twins included a range of technologies, multiple platforms, adoption of new and leveraging existing data infrastructure with the government departments, and a combination of custom integrations with commercial off-the-shelf. All programs, however, require decisions on systems to use for user authentication and data authorization integrations. In our final slide, I'd like to acknowledge again the contributions of our key partners, New South Wales, Queensland, and Victorian government, and say thank you. Should you have any questions, please reach out on using the contact details on this page. Thank you.
Okay, thank you so much, Aina. Actually, she's in Australia, so we do not have a Q&A session. So we'll move to the next speaker. The next speaker is Deputy Director of the Ministry of Land, Infrastructure and Transportation, Korea, Mr. Kim Si-jung. He will talk about the frontier of digital twin in Korea. So he will talk. Yeah, he will give a talk in Korean. So you please switch to the channel 2 for the English translation. Please welcome Mr. Kim.
Hello. I'm so honored to be at this meaningful conference. I am from the Ministry of Land, Infrastructure and Transportation, a government body of Korea responsible for all the land management. And I actually have been working on this topic of digital twin, which is like a cutting-edge technological field, and we'll be presenting on what the government is doing related to the digital twin. So I will be first going through what we have been doing and what were the progress that we have achieved. First, this is my table of contents. First, what is a digital twin? Well, this is like a cutting-edge technology. So different people have different concepts about digital twin. We at MOLIT look at it from a little different perspective compared to other government ministries like the Ministry of Science and ICT. So based on how you look at this concept, the data platform and the simulation, all these components can come together. And from our MOLIT's perspective, I will be explaining to you what a digital twin is. For the past 2 years, just like what one of the movie commentator has said, I felt like the creativity of the modern society is not about creating something out of nothing, but it's just about having creative realignment of what has been in the world already. And I think that can be applied to digital twin because it's not like a totally new concept or totally new creation. With the AI advancement, we have like data also being advanced and other technologies also have developed. And how we look at the space and how we analyze the space have gone into another stage. And it's not like anything new, and it's not a totally new technology. actually, the commentator, the movie commentator, he said this for the movie Matrix. So for digital twin, there are three components. First is data, of course. In the past, there has been very low level of map or 2D maps, but now there are higher level of more sophisticated maps or various layered maps coming into play. And after data, what we are considering as another component is for us to use the data. In the past, we just had the map as like a surface information, but now it doesn't end there. Now the map goes inside a machine or platform, and it allows us to use it further from there. In the past, if we were to measure distance, of course, we had to measure it by ourselves. But by putting the map on the platform, we can do that automatically through calculation. And through that, it will allow us to do better decision making. And that is what digital twin will support us. It's like creating something that mimics the real world in the cyberspace, and by using the analysis function, you can get support in your decision making. That's what digital twin is about, and based on that understanding, we are implementing digital twin at Molit. So in the past, we just had the map in our digital twin area, and that was only based on the space data. But now we can connect all the data based on the location or geographic information. And we also have other technologies like AI technology and big data technology to analyze them better. So CCTV allows us to get real-time data in very complicated way. So the location information is received and then they are analyzed on the system. And it allows us to have better use of the space information. Then what is the 3D spatial model that we are dreaming of? In the past, we just had the 2D spatial model, meaning that there is only x-axis and y-axis, but now we have the z-axis. So if by analyzing this third axis, it can go upward or downward. Downward means it's going to the underground space. So we can create information about the underground space. And for the upward information, it's like or aerospace related information that can come into play in our system. So when we say it's like 3D spatial model, it is like making the 2D model more sophisticated and having the underground information and the above the ground, the aero level information to be embodied in the system. This is the 2D map. In the past, we had 1 to 5,000 scale map. And what we could see here was not very detailed. But now it will become even more sophisticated to eliminate any errors. It will reduce the range of errors and help us better in our decision making. So in the new map, it will show you more details like where the fire extinguisher is located, and it will allow the UMs and other autonomous vehicles to use them for their operation. Now we have this 3D map, and what is the most important for the 3D map? Actually, the box, what comes inside the box, like the objects are very important, and we will be focusing on buildings in our case. So this kind of LOD, one level of box-based object, the buildings will be the main target for our recognition. But actually, they have limitations in the perception because in case of the rooftop areas, there could be the rails and the gates, and they might not be recognized. However, that is what we are going to do at LOD 1 level, and we will further expand to other LODs later. Here you can see that for 3D spatial model, we have the underground information and road information and the above the ground information. For the underground information, we have 16 different types of underground facilities. They will be using the already existing underground information that we have in the system, and they will be integrated in our 3D map so that we can use them better for our urban planning and urban construction. And another thing is the precision map that we can use for the autonomous driving. In the past, actually, this map was created just for safer operation of cars on the road, but now we can refine this precision map further to allow it to be used for the autonomous driving. The other one is the satellite map. The Ministry of Land Transportation have launched the number 1 satellite for this purpose, and later we will be launching the second satellite. However, due to the conflict in Ukraine, the launch of the second satellite is being delayed. Next is about platform, that the third component. Actually, we have some homeworks or challenges to resolve in regards to platform. Because for all the components of digital twin, they are not anything new, but they just have evolved. So it means that we are not creating anything new or deploying anything new, but they already exist across various platforms or systems that we already have in the government. So the platform that we use to gather data and also the platform that we use to send information to the public are already out there, but they are scattered. So in order to operate those platforms in very efficient way, to create the linkage, actually there, Ministry of Land and Transportation has very important role to play. So in that regard, we have 2 platforms. One is KG, where we gather critical information about the land and the road operation of Korea. And for the information that we gather here, we send it through 2 channels. First is the V word. It is targeting the public, and we do the simulation on this system. The other one is LX platform. There is our partner, the LX Corp, and we work together with LX Corp to provide this platform so that we can support the digital twin services. I will show you a simulation later to show you what kind of issues we have. Well, simulation, it might sound easy, but actually it's not always so easy, because as for the spatial information, the geospatial information, it is something that we have to create by using data. But we have to have the expertise incorporated with that to create the proper simulation. For example, if we want to simulate the stability of the underground or to simulate the road congestion, just having information coming in from sensors or platforms already out there would not allow us to have the proper simulation. We have to also apply sophisticated and professional expertise for it to have meaning. It has to combine with various information and get advanced or evolved further, and to allow that people at our department has to work with people from different government ministries and agencies. However, it might not be as easy as it sounds, because that kind of cooperation, cross-functional cooperation, is not that easy in practice. So what we have done was we have provided some funding to local governments to run the simulation together with local governments. To start, we selected 7 local governments. And there are different departments at those local governments who were working together with us, And then it was like a pilot for the simulation. And based on this pilot, we wanted to expand it to the whole nation. This pilot was mostly focusing on resolving any issues or hurdles that the local governments are having currently. So there are 7 projects in total, but of course we were not satisfied with all the 7 projects. We have supported all the 3 local governments, and actually it was the process of finding out which one would be working out the best. So I'll later explain to you which project had the best result. In this case, it's Incheon City, and actually we thought that this might be the easiest project, but we thought this is also very important project. It's related to the firefighting. So we work together with the fire station of Incheon so that what the firefighters need in terms of the spatial information was developed. And actually it was quite effective. So I'll be watching the video clip together with you. So in Namdong-gu, in the system they had this limited function for the navigation because fire cars, they can ignore the traffic signs, and actually fire cars are very big compared to normal vehicles, so there was no dedicated navigation function for fire trucks. So now this system has allowed this 3D modeling to identify any dangerous spots in advance. So firefighters, before getting dispatched, they will know where dangerous items are located. So if there are any dangerous items inside the building, they will know that they have to pay close attention to that specific floor, and they will be holding a tablet so that the firefighter who goes inside the site, actually they will be notified in advance, and also they can communicate on the way to the site to be aware of those dangerous objects. And here you can see that people being dispatched and the people still working at the station could communicate or discuss ways to extinguish the fire in the best way, in the most efficient way. And for any patients or people who need to get the treatment, they also have the communication based on this geospatial information. It's not in the video, but in case of like an emergency case, if there is like a patient who needs to get treatment for emergent case, then based on what kind of injury the patient has suffered, there should be specific hospitals that the patient has to be sent, and it is also being notified by the system. This is another project, and this is like a second round of the pilot project. We have actually separated different business fields or business topics. So here you can see that we have classified into different categories like transportation, logistics, services, and etc. What we are most interested about is for Cheongju City and Seocho-gu of Korea. They are about transportation, the traffic congestion. So we thought that for the simulation to have the greatest impact, it has to provide the calculation function. And we believe that the best result could be achieved for the transportation because we believe that all the cars will be following the transportation rules and regulations. If you see what the private sector is already doing, they do the calculation based on the estimated traffic and also calculate the time needed to travel to that destination and which route would be the optimal route. So it means that for traffic, we can get the best outcome by using this calculation method. So Chungcheongnam-do, Seocho district, and Cheongju, those are the selected local governments, and currently they are being implemented. What we are also discussing with the Ministry of Industry and Ministry of Industry is that before they give out the license to construct factory, actually we allow them to run that on our system in advance to see whether granting the license would be appropriate. So you can see that we have to discuss directly with related agencies to come up with better results. Thank you for paying attention to my presentation at MOLIT. As I already mentioned, we are not trying to create nothing, something out of nothing, but what we are trying to do is to work together with various stakeholders to create creative ideas so that we can implement a digital twin for the public sector.
질의응답을 안 하실 건가요? So we can have one or two quick questions. Do you have any questions from audience? No?
It's not open source, open data, and various companies or organizations have their own data for different areas and uses. Yeah, I am not a specialist, so I apologize if this information was wrong, but I have heard there is recent movements to integrate data on underground in Japan. Now I'm curious about the situation in Korea. How do you collect data on underground deposit?
이 지하 공간 정보에 대해 말씀하셨던 것처럼 이게 상당히 어려운 부분.
Well, as you just mentioned, it's quite tricky. I mentioned that there are 16 different categories or facilities for the underground information, but actually the owners for those 16 facilities are different. For example, there are sewage pipes and the different underground facilities, and there are different agencies who would be owning that, and they collect them separately. So it's very difficult to have an integrated management of all the 16 underground information. So what we are trying to do is to collect them as at the center and then put them on one platform and have 3D map. But actually, what is important is that even though the owners or the responsible parties for those 16 different informations are different, by gathering them at one point, we can have more precise management and 3D embodiment. But as I mentioned, as the owners of these informations are different, it's quite hard to gather them precisely.
Thanks to Mr. Kim Si-jung. Thank you so much. And we'd like to move to the next speaker. Next speaker is Yuri Tsubaki. She is from Japanese government, and she will talk about the Project Plateau, the Japanese digital twin initiative. Please welcome Ms. Yuri Tsubaki.
I already sent it. So I just want to see the Okay, thank you for your time today.
네, 오늘 시간 내주셔서 감사합니다. 오늘
And responsibility. The name is Project Plateau. I'm Yuri Tsubaki. I'm the Deputy Director of Urban Policy Division from the Ministry of Land, Infrastructure, Transport and Tourism of Japan. So, what is Plateau? Plateau is a project by MLIT that focuses on developing, utilizing, and sharing 3D city models. We are working together with lots of local governments, private companies, and academia. This is a project everyone can join and enjoy the possibility of 3D city models. 감사합니다. The project mission is we create a new value in a society and solve local issues through the digital twin. We started this project on 2020, so this is the fourth year and more people have a chance to use 3D city models now. As you can see, we create the data for various urban features such as a building, transportation, city furniture, zoning area, and disaster risk information. Currently, data for about 130 cities has been developed or updated. Plateau's data is not just a geometric model. It is GIS data that contains various urban information known as semantics. Using this structured and rich information, we are developing solutions. As I show you later, actual use cases has been created in various fields by leveraging the open data provided by Plateau. The value Plateau offers is high quality, open data, data structuring. I'm explaining in detail. At first, why I can say Plateau's data is high quality. In Japan, there is City Planning Act, and under this act, the local government conduct aerial surveys regularly and product the urban planning base map. This is the basic data for Plateau. Particularly important is Japan's rules and regulations for aerial surveying. In Japan, aerial surveys are conducted with consistent quality by local governments. Under these regulations, Plato's data are accuracy controlled within a horizontal deviation of 1.75 meters and a height deviation of 0.66 meters. That's why Plato's data is high quality. Another important aspect is leveraging the data from the Urban Planning Basic Survey. Local governments regularly conduct surveys to gather information on land use and building utilization for urban planning. By utilizing this existing information, Plato's data becomes even more comprehensive and detailed. Before Project Plateau started, this useful data traditionally has been limited to internal use by the local governments. The most important point of this project is to reuse such kind of useful data and open it for everyone. As I mentioned, Plato's data is developed by local governments. So data standardization is very important because there are more than 1,700 cities in Japan. We developed a standard data product specification for 3D city models. The knowledge of our partner Azure Air Survey devotes so much to this initiative. By developing this document, we have unified the specification, standards, and quality of methods. We focused on adapting international standards to enhance the interoperability of models. As for data model and format, we adapt to CityGML 2.0 defined by the ODC, and we have localized CityGML for Japan as well. The standard data product specification also provides detailed definition of LOD, level of detail for each feature. In fact, Plato's data created in the first year resulted in different cities having different levels of detail, even when the same LOD was applied. Please look at these two figures on the right side. These are both LOD2 buildings, but they are different in the details of the wall shape and the availability of building installations. Fortunately, this challenge was solved by Professor Philip of National University of Singapore, his research of LOD refinement. We localized LOD refinement with respect to data utility and simplicity of data implementation in Japan. LOD2 was subdivided in terms of the range of details that can be created using aerial photos. Roof shapes were defined from LOD 2.0 to LOD 2.2 from the perspective of detailing roof shapes. In response to this, LOD 3 was subdivided within perspective of detailing the wall shapes. While the exterior of LOD 2 and LOD 3 could be obtained by surveying, it is more effective to use BIM models for the interior. As such, the refinement of LOD4 was done on the assumption of using BIM models. So next is, why do we insist on open data? Plato's data is available from the Geospatial Information Center. Plato's data has been widely downloaded and utilized in various commercial and personal applications. Not only data, but also all software developed through this project has been released as OSS. These are products or events which Plato's data is used. A common point among cases is that they made possible by data that has high precision location information and is commercially available. Especially when creating or measuring city models from scratch, the cost can be very high. Plato's data is very useful because it can be used for free. And these basic geo-information are devoted to call for the investment to the city. Furthermore, we place emphasis on tech community building. Open data has meaning when it is used. To enhance the technology for handling city GML and other digital twin data throughout Japan, we organize various development competitions, hackathons, and workshops. As a result, there's been a lot of buzz and excitement in tech community like X, GitHub, and local tech events, with people showing the wide range of products using Plato's data. I'm explaining one of the most important features of Plato. Plato's data is not simply CG data made up of mesh, but structured data that expresses the meaning of urban space. For example, LOD2 building models define distinct objects such as roofs, walls, and floors. And we can see the building and recognize where the roof and where the walls, but the machine cannot recognize them as human brains do. For example, each mesh of the roof has latitude, longitude, and altitude, and the information that this point of the part of the roof. So the machine can understand the place and meaning of the city. In addition, Plato's data has semantic information such as use, structure, year of construction, etc. This feature enables more detailed analysis of entire city, such as areas where buildings are prone to collapse due to the earthquake or floods. As I mentioned, we published the 3D city model as open data. However, it's not enough. There still is a gap between 3D city model and people without special knowledge of GIS and IT technology. So we continue to try to make it more easily usable. There is an important technology called Plateau View. It is a WebGIS application developed by our wonderful partner, Eukarya. If we use the private GIS viewer, only people who have account can see it. That's why we developed the WebGIS application from scratch, and everyone can access it on the website of Japanese government. Let me explain a bit more. Our Plateau View consists of 3 subsystems: a rendering function based on Cesium, a database function for data management and streaming, and an editor function for editing the user interface and the style of the viewer. All of these are provided as no-code solutions. In our division and most of local governments, there is no engineer. The development of this application will enable us and local governments to easily manage and visualize 3D city models. This is also an innovative development to use Plato's data easily. Actually, CityGML is not suitable data format for QGIS, which is one of the most widely used GIS software. Therefore, there was an issue for importing Plato's data. However, Plato QGIS plugin, developed by our great partner Mielnet, make it possible to import the data very easily. Let me introduce another important tool. It is a Plato SDK for Unity and Unreal Engine. This remarkable job is developed by Synastagios and Unity. This tool makes it very easy to import and edit 3D city models in game engine. It's very important that we can use it in game engine to simulate in cyberspace and create application. We also develop SDK toolkits, which offer a lot of useful toolkits, such as map toolkits, the AR toolkit, the rendering toolkit, and the sandbox toolkit. It helps you to create application easily. We have also released these as OSS on the GitHub. So let me introduce what we can do by using Plato's data. A wide range of use cases has been developed in various fields, not only in urban planning and disaster management, but also in tourism, energy policy, infrastructure management, and other fields. At first, I'd like to show you the use case for disaster management. This is an application that shows the temporal changes of the routes to evacuation place when a river overflows and how they eventually become cut off. This is a point of
This is a point of overflow. And this is a evacuation place, school. And this residential area. Okay. The water from river is spreading. And we can see the height of water very easily like this. It also allows you to visualize the water level in actual city using AR technology. These white points are the evacuation route. And if you are delayed, the height of water reach at this level. It is useful for residents to simulate the optimal escape route from their homes and to visually appeal to them that if they delay their evacuation, they will lose their route to escape. Next one is use case for city planning. In Japan, there are many types of landscape regulation. In the historical cities, there is a regulation called viewpoint regulation, which prohibits buildings that are so tall that they block the view of the historical buildings, such as castle. There is a castle on the hill, and you cannot build higher than this red line. This green line shows how the castle appears from the viewpoint. You can simulate easily at this picture that the building you are planning is higher than the regulation. These regulations were traditionally examined on 2D maps, but by using 3D city models, these regulations can be easily visualized. So this is a simulation for a crowded simulation. In this case, we utilized LOD4 building models, which are derived from BIM models. We can represent the inside of a building and simulate how people move from inside to the outside the evacuation place in an emergency situation. These models serve as maps for conducting agent simulation involving a scale of over 10,000 individuals. For such kind of big-scale simulation, we can not do that on the real world. Through this calculation, we can effectively plan evacuation strategies and control pedestrian flow at the block level. This is a tool for the urban planning with using game called Cities Skyline. We have developed and published an extension program that allows importing Plato's data into this game. We can play with the data of actual city. By using the game platform, anyone can engage in urban policies. It can be also used for educational objects. The students can learn policies in a fun way by playing this game. Next is a use case for urban planning with participating citizens. Visualizing urban development plan is also effective for discussing with citizens. Until now, urban planning was difficult to participate in without specialized knowledge. But with Excel tools, you can easily visualize the image of development. In fact, some local governments held workshops with Excel tools that display buildings on the screen when cards are placed. So the local government can listen to the citizens' opinion before actual development. The AR technology enables us to experience the idea of urban planning in a real city. This is an image of the sidewalks were widened, overlaid on the actual street. The plan created in cyberspace can be easily represented in the real world like this. This is due to the high positional accuracy of Plato's data. Plato's data is also used for product of tourism. The metaverse is a useful tool to let us experience the local atmosphere at home. The basic data can cut the cost of making the metaverse contents. The metaverse contents located in Kyoto come river. By creating such detailed models, we can express the beauty of the city in this way. And we can hold a fireworks event like this without any regulations in the metaverse. The 3 years has passed since the project started. The number of city models has been increasing and is expected to reach 200 by the end of next March. I believe there are more and more local governments join the project and widen the potential of each city. We have many partners and we are looking forward to growing this project together. We have the booth at the exhibition, and please come to our booth, and maybe someone come earlier, you can get the Prato t-shirts, same as me. Thank you so much.
Okay, thank you very much for your great presentations. Any questions from audience? Okay.
Thank you. Very impressive presentation. My name is Dae-jong Kim. I'm working at CRIS, Korea Research Institute for Human Settlement. I have a question about your use case. Do you have any policy to promote that kind of use case? Do you support budget or what today or private company or individual, they are developing that kind of use case their own self? Do you have any policy for use
Policy
case?
for developing use case?
Yes,
you mean?
right.
Okay. Yeah, and this project is fourth year at this year, and until this year, the initiative for developing use case is led by the government, us, the Ministry of the Infrastructure. But we want to build the ecosystem to utilize the use case for private companies and local government. So, and we have we subsidize for local government, so they can use these subsidies for developing models and developing the use case as well. So I think the initiative of the developing use case is moving to local governments.
And another questions? Actually, I have a question. I'm a Korean. Can I download your CityGML data from your website?
Sure.
Okay.
Yes, everyone. No border.
Okay, and I also have another question. Actually, in terms of the standard, you mentioned the CityGML 2.0, actually, but I don't like the CityGML. It's too verbose and the size of too big, and that does not have not so many real value. So, actually, do you have any idea or opinion regarding the CityGML 2.0? Frankly, to say, I don't like CityGML.
It's very difficult question, but at the website, and we have another format of data as well. So you can download another format, and we have many types of converters. So we don't insist on using CityGML.
Okay, thank you so much. And then we can have one another questions. Any questions from audience? No? Okay, thank you so much, Yuri.
Thank you.
And I would like to introduce next speaker. Next speaker is Diego Gonzalez Ferreiro. He's working for the United Nations Global Service Center, and he will be talking about the digital twin in United Nations. Please welcome Diego.
Okay. Good afternoon, everyone. So, yeah, my name is Diego González. I work for the United Nations, the Global Service Center. We are based in 2 offices, one in Spain and another one in Italy. And first of all, I want to say thank you for the invitation. It's an honor to be here. So, what we do in our office is to develop geospatial solutions and tools specifically for the benefit of our colleagues in the peacekeeping missions and political missions, mainly in Africa and the Middle East. So what I've seen so far in Digital Twin is absolutely impressive. And you are very lucky. You are very lucky in Australia, in Korea, in Japan, because you have data. You have lots of data. And the governments take care of that. And that's extremely important. For us, we have a big challenge because in the areas of interest of the UN, there is nothing. There is absolutely nothing. So sometimes we have to develop it ourselves. Sometimes we have to create it out of scratch, out of nothing. And even sometimes we have to estimate it and invent it. So that's the situation that we have for the digital twin. So we have understood in the UN basically the benefits of the 3D data. We have realized about how we are able to engage with the audience with compelling visuals, something that is important. We are able to gather information out of the 3D data that otherwise wouldn't be possible with 2D volumes of buildings and structures, the terrain, different terrain models, etc. At the same time, with the 3D information, we are able to create a better understanding of our surrounding, something that is extremely important to carry out our daily operations within the UN, especially in the field. So we have a better spatial context and even a better visualization. And even we understand that having immersive experience, XR solutions are very important for further collaboration and further initiatives. So that's why we've been already developing in game engine solutions so that we can have a better immersive experience. And at the same time, and most importantly, we understand that with all this data, we are able to provide insights and analysis for the decision-making process of our colleagues who are in the field. So one of those aspects that we have created is the UN Globe, which is part of the entire UN Maps ecosystem. In this case, we are adding relevant operational information and terrain information, everything combined to provide additional data and information and insights for our colleagues in the field. For example, some of the layers that we have, that we include there are the 3D base maps, also deployment of the blue helmets, the troops that we have on the ground, 3D related information of UN camps, buildings, the air supply routes, for example, or any other information that is draped into the 3D environment. We integrate within the UN Globe relevant information, not only the geospatial, but also the drone imagery that is being captured. And we combine this with specific 3D models as well. That's why we have created, finally, what is the digital twin service. And I just want to put you a little bit in context. We have about 500 camps or sites that are managed by the UN, and specifically the Department of Operational Support in the, about 30 special political missions and peacekeeping missions. So what's the objective? Why we want to create the digital twin model within the UN? For us, it's important to streamline all the operational activities and specifically enhance also the safety and security. And also to optimize the management and the planning of all those different camps. That's very important. But at the same time, we realize that we need to maintain operational resilience. We are living in those camps. Our colleagues are operating in harsh environments in terms of climate and weather, and also security. So the needs are different than the ones that we can have, obviously, in in the other areas, like for example here in Korea. Our colleagues also are living in areas where, as I said, there is a scarce data, and the integration is difficult, and also have a low bandwidth in terms of the consumption of the solutions. So we have created virtual 3D models of different LODs and levels of detail at the camp level and also at the city level. We are using as the source of information mainly drone imagery in those areas where we can fly those drones. We process them with Open Drone Map, for example, and we make sure that we integrate all those 3D meshes. We also add all other cartographic information, and we do all the processing through photogrammetry and creating the different models. So that's an examples of a few data models that we have created. We are now in the middle of a process of creating also a library of 3D assets, and we are adding also indoor mapping with BIM and CAD models. So what are the main use cases and examples? I just want to mention about the UN camp in Dukra. Dukra is a remote location in the UNISFA area between Sudan and South Sudan. It's very different to Korea. It's a very, very harsh, very difficult environment with over 40 degrees of temperature on a yearly basis, with a very strong dry and also a rainy season. So the areas where we operate are definitely very different. So what are those fields of application? We have created those digital models for flood impact analysis, disaster management for our colleagues. We are creating what is called the UN Smart Camp. We want to integrate real-time information within those UN camps so that we can have a better analysis and decision-making process. We integrate information related to security as well. For us, that's very important to include analysis on the planning and the patrol simulation and the viewshed analysis with the CCTV cameras. We have even created a serious game with the 3D rendering digital twin for game engine SDKs, so that we can engage better in coordination and training of our colleagues in the field in case of evacuation, for example. And we have many other use cases related to the environment or the natural resources, and also the utilities and the facility management. One of those examples that I wanted to show you there is the digital twin that we are developing, what we call the UN Smart Camp. In this case is in Dukra. And as you can see, we have modeled everything from scratch, apart from creating the 3D mesh from the drone imageries as well. So everything is interactive, but at the same time, we are also creating digital twins of larger areas with obviously different levels of detail. In this case, is the city of Bangui in Central African Republic, in which for some buildings, we model them completely out of the information that we are getting from a street level imagery that is being provided, for example, by a Mapillary or CartaView. So we take this information, we model specific buildings that are very, like landmarks, that are really important for our colleagues in the field. And for the rest of the buildings, we just extrude and the volume of the building footprints coming from, mainly from OpenStreetMap with additional texture. So this is just two examples, one in Dukra. What we are trying to do is to go systematically, one by one, to all the different camps that are in the peacekeeping and political missions, flying drones, getting all the different models, integrating, obviously, all the operational information that is relevant for our colleagues in the field, and creating as detailed as possible information and adding relevant data for the specific camps with, for example, underground utility pipes for water, sewage, and electricity. We are modeling all the different buildings outside and inside in those camps. To provide additional information and planning for planning purposes, no? So that we can better understand the surrounding. At the same time, we have a different use case related to security with the viewshed analysis and CCTV cameras, and also the flood mapping to understand what would happen in these frequent cases with flooded areas. So what needs to be done in those cases. Another level of detail, in this case, is an example of Tripoli. We are extracting information from OpenStreetMap, as I said. We are adding all the volumes and the heights and the type of roof from OpenStreetMap, and adding also the texture for the entire city, and specifically model with Blender for those specific buildings that are considered as landmarks. So this is something that we continue improving. But the real benefit and the real added value is the integration of that visualization and that information with additional data. We have embarked into what we call the Unite FRIM. FRIM stands for Field Remote Infrastructure Monitoring. Is really the IoT, the Internet of Things program that we have established in the Department of Operational Support. We have already installed hundreds of sensors, and we are adding thousands of tags for those sensors that are attached to specific assets that our colleagues in the field want to monitor. That's why we are now taking real-time information from those assets and integrating them into our digital twin.
The United
So
Nations
I just want to
Global
give you
Service Center has developed a powerful,
a video.
cost-effective, large-area digital twin 3D model production service which can be deployed to all field operations. This service is a key component in the UN Smart Camp 1.0 initiative alongside additive 3D printing, UN maps, extended and virtual reality, and other enabling technologies and solutions. UNGSC can support the creation of 3D digital twin models for large urban or rural areas through satellite imagery techniques, as well as more detailed models through combined imagery taken from multiple drone flights over UN camps, and anywhere drones are permitted. UNGSC's in-house 3D model generation capacity, alongside a portfolio of contracted services, provides for a rapid and scalable production. This technology gives the UN the ability to twin any operational environment for a wide range of safety, security, engineering, logistic, or virtual and mixed reality applications. The Virtual Operations Center uses a digital twin of the operational area and mixed reality to model the environment for extensive safety and security planning. Advanced features include blast analysis and patrol simulations, as well as the ability to layer GIS and operational data for analytics or real-time monitoring. UN Smart Camp uses a digital twin of the entire camp and virtual reality to model the camp and its infrastructure. Security systems, engineering installations, GIS data, operational layers, and Unite FRIM IoT sensor data can all be mapped onto a Smart Camp digital twin. Linking historical and real-time data along with artificial intelligence and machine learning could help improve operational efficiency on multiple levels. Digital twin models can also be inserted into the UN Maps environment, making them widely available through any device, as well as integrating UN Maps search and navigation tools, including operational layers and IoT layers, with the digital twin. UN Camp digital twin models can be further refined and developed into virtual serious gaming environments to provide accurate 3D camp models for situational awareness simulations, camp attack simulation and evacuation training drills, and safety and pre-deployment training for UN personnel. The UNGSC Digital Twin Production Service can provide digital 3D duplication of entire UN camps, as well as surrounding operational areas, on large scales. The service is readily applicable to any mission, and can be easily integrated and rolled out through UN Maps and extended reality alongside the existing technology expansion strategy of widespread UN Smart Camp deployment.
The last application that we have developed already and that we are going to implement in many of those UN camps is a specific interactive application that is used also for planning. So we are able to integrate 3D models and assets within the digital twin on a web application, and we are able to do the planning, moving the different assets, containers, prefab structures, and warehouses, etc., for better planning of an increased decision-making process. No? Thank you very much.
Thank you very much, Diego. So we can have one or two questions. Any questions? Come on, don't be shy. Please ask a question. Okay.
Thank you for presentation. What about the possibility for using digital twin, other bad guys like the terrorists using a UN digital twin? So
sorry,
what is
bad guys like a terrorist.
Terrorists.
In case
like use
there is
UN digital twin, like
exactly. That's one of the specific use cases. That's why the safety and security aspect of the digital twin, when it comes specifically to the planning and operational activities of the camps, is extremely important. That's why, for example, the CCTV cameras, we have created an application in which we are able, based on the specifications of those CCTV cameras, in terms of the range and the view and the angle, to understand if there are blind spots or where they need to be installed as well. No? We also have within the digital twin, I didn't put it in the presentation, but in the application that we have already developed, we have created interaction of objects, and specifically of the observation posts. So the user can go in a first view, go up the observation post, know exactly what they are able to see outside the perimeter of the camp, to analyze potential attacks from terrorists, for example, and also identify the line of sight and the information related to the view shed, so that it's really important for security. No? There are many different use cases, but that's a good question. Yes.
Actually, I thought that there's a possibility that other guy than the UN, the terrorists, can also make use of your digital twin platform. Was like a hacking or something.
This platform is within the UN, within the UN network, and it's secured also within our specific Active Directory. So this data really is not for public consumption. So it's within the specific intranet. That's why we take it very seriously, no? The information.
But maybe in future prospect, you can use make the citizens' life better with using a digital twin platform. Yeah. So in that case, maybe there's some leak of data, digital twin data, like to the other bad guys.
Well, the information that we provide is in OpenStreetMap, for example. So we try to improve the completeness and accuracy of OpenStreetMap in specific areas in the Middle East and also Africa. That data could be used by the bad guys, but it could be used also for urban planning. It can be used for many good things. So that's the added value and the benefits that we are providing to the community.
So the data is also open for all the people.
It's open data within OpenStreetMap with all the building footprints, all the volumes. We have even created a branch of the Street Complete application that we call it Building Complete, to provide users in the field the ability through their mobile phones to add additional information related to the height, the type of the building, the type of the roof, and some additional information. That's open data. That's available by everyone, by the bad guys and the good ones.
Okay, thank you.
Diego, I have a very quick question.
Yes.
Do you have any plan to collaborate with UN member countries like Korea or Australia, Japan, United States?
Yeah, we will be, and I call out here for collaboration and partnership, definitely. I think it would be extremely valuable if we can learn from you, your experience, your use cases, your background, the technology that you use, and see, depending on the use cases that we have on our side, if they are applicable. We would be extremely happy to collaborate. Yes.
Thank you so much.
Thank you.
Thank you. Bye-bye. So we would like to move to the next speaker. Next speaker is Mr. Park Hyo-chul from LH company, a state-owned land and housing company. He will talk about LH Urban Digital Twin. Please welcome Mr. Park Hyo-chul.
안녕하십니까. 저는 오늘 LH 도시 디지털
Hello, my name is Park Hyo-chul from LH. There are three main things I am going to talk about today. First, I'll give a short introduction to LH. and our strategy for building digital twins. And finally, the key features that we have on the platform today. First, I am going to do a short introduction of LH. I'm introducing our company because we have our international attendees. And by introducing LH, I think it will help you understand why LH created and uses a digital twin. First of all, this is the mission of the LH. LH is established to lead the improvement of life quality and national economy by providing stable residential environment and making efficient use of land. It is established by merging two companies who was in charge of housing and who was in charge of the land. And these are various business areas of the LH. New city development, public housing construction, residential welfare projects, industrial complexes, urban regeneration projects are some of the business areas of the LH. I'd give you a quick rundown of what LH has been doing in numbers. First, in housing, we own and manage 1.3 million rental housing units, or 77% of all public rental housing in Korea. In terms of cities, excluding existing settlements, we have developed about 80% of the nation's residential land area, and we have established 14% of the total industrial parks in Korea. And let's talk about LH's financials. LH is a public institution 100% invested by the Korean government. However, it has the fifth position in terms of the asset. And we have 38 trillion won, and that's about 30 billion US dollars. And out of 13 million housings, 3 million people live in those housing. And that was the main businesses of the LH. As you can see, LH is mainly engaged in planning and executing housing policies, and it is still is in charge of 60% of the rental housing construction. In this section, I am going to talk about LH's strategy to establish urban digital twin. Each organization is making a digital twin to fit its purpose. As I mentioned before, as with the business area of the LH, LH uses digital twin to support decision-making process to solve urban problems. In the past, the bird's eye view was used very limitedly in planning cities, and now we would like to make digital twin that's very dimensional, so we can use them for the whole life cycles of the urban planning. And under division of innovating the urban development process, we have established a strategy. First of all, of course, we would like to establish a platform based on the international standards. There are many stakeholders who will be participating in a project. Of course, planning and in executing as well, there will be many entities participating in planning, construction, in the life cycle of a city. When there are many participants, and the entity will be diversified according to each process. And the first primary creator of the data and the updaters of these data are different. And the different data should be integrated, and the international standard should be used for that, to be used for the digital twin. And second, we want to expand the platform, making use of the cutting-edge technologies. So first of all, we would like to establish a basic platform, and then we would like to continuously expand the platform using the AI technologies. Of course, for the expansion, platform-based sharing should be established. 3D data analysis web-based platform should be first, and then on top, there should be a platform that can integrate each application. For this integration, we need to meet two standards of expansion and stability, and we came up with the open source strategy. In strategy 5, we have to incorporate city construction life cycle. And as a person or as an entity that plans the city, we have a differentiator with other entities engaging in digital twin. Because we want to use the digital twin in the entire life cycle of planning, design, construction, and maintenance. And based on this, we would like to establish a reference cycle that can be a world class. And we want to contribute to the competitiveness of the smart city that's built by the LH. And I've explained the strategy of the LH so far up until now, and we've established it 4 or 5 years ago. Now that I think about it, it's really as close to the basic principle rather than a strategy. So we are establishing the digital twin based on these basic principles. And now I would like to move on to the main features of the digital twin, but before that I would like to talk about the history. First of all, we started with the National Pilot City DT development, and then DT phase 1 development and phase 2 development, and we are in phase 3. We are preparing for the phase 3. And this is the screen where you can see various service features of the LH. This is displayed as a site map. So on the left, you can see urban planning features, the features that can be used for construction, and also the features that can be used for urban management. First of all, I would like to introduce to you Population and Housing Planning Review Service. It is very frequent that housing planning is updated. For example, for the amenities of a city, you sometimes are asked to reduce the number of houses and also to fit to the government policy. Sometimes we are asked to increase the number of houses, and this is the feature or the function that can use in that cases. So in this target area, you select one specific area, and then you can adjust the height, and you can check the different number of population based on these adjustments. And now you can see how the density of the whole project area changes according to your adjustment very easily. And second of all, I would like to introduce to you this function. And this is a function that we established together with the SMEs in Korea. It's a AI-based architectural design solution. And this slide shows how this is integrated with the LH AI-based design solution. If you ask automatic allotment, then the AI model creates about dozens of the results. This is the result that the AI created.
사용자는 AI가 생성한 10여 개의 배치안 중에서 최적의 배치안을 선택하거나
The user can use the optimal result out of all these results, or the user can use the edit tool to make some fixes.
AI가 만들어낸 성과물들이 좀 어떤 것 같은가요?
So how do you think about these results that are made from the AI? The screen you're seeing right now is not just the placement of the AI, and this AI also reports the area, common area, and also data that are needed to analyze business profitability. And you can also download the file in CAD form. And you can also download the report in other formats. And next, this function is IoT sensor-based construction site safety management. So this is a case that we use this function to an industrial complex that's being built. So we attached sensors to the construction site and the builders there. And we overlaid the video that we took with the drone with the map of this target area. And you can see the movement of equipment and people visualized in the form of a heat map. Not shown in this video, but after setting a danger zone, you can also set up warnings or notify managers when equipment or people approach. So this is the same function, and this is an example of applying the construction safety service to an apartment building site. First, the apartment under construction was modeled in 3D and built on digital twin first, and installed sensors indoors to recognize the location of workers even in spaces where GPS signals cannot reach. Through this, even though it shouldn't happen in the event of a disaster in the field, we can easily locate workers. And the sensors on the gyro sensors on the workers' hands can be used to automatically detect the field workers and alert the managers immediately. And this function is a case of a building an underground facility in the government building. You can adjust the transparency of the surface to view three-dimensional underground facilities. You can also view the depth of burial and the properties of the facility through the cross-sectional view. And you can use the virtual excavation function, and you can use it for the operation phase. The features described so far are those that can be accessed and used on LH's internal workers. But from now on, I'm going to show you a public service, and anyone can access them on the web. Before I explain the features, let me tell you about the background of the service. 2 years ago, when the housing prices were going up, to stabilize the demand, we adopted a system which is called pre-subscription. So this is a system that accelerates the subscription by 1-2 years earlier than the pre-subscription. By this, the people who are participating in this cannot easily get information. We wanted to resolve the imbalance of information and adopt it and introduce this system. As you can see, this is a bird's eye view of the business area, and these are the details of this business area. And you can also see the land planning here, transportation plan, and the major SOC facilities like the elementary school, just at a glance. And the general public cannot see the zoning, and now the UI is very convenient to use. And for the pre-subscription blocks, we have a section where you can see the whole view, and you can select the building that you want to pre-subscribe, and also the level inside the building, and then you can see the outside from the inside of the building that you selected. And the targets for this pre-subscription are most curious about where the elementary school is, how far it is from that building. To show you the road to the elementary school, we just made a virtual driving service. So you can experience virtually how you can go from your site to the elementary school. So that's it that I prepared so far. Because of the time limit of the 20 minutes, we have so many features, but I should just wrap it up right here. And as I mentioned before, we are preparing the phase 3 platform, and the LH digital twin platform is ongoing, and in phase 3 we would like to do noise analysis and transportation analysis module, so we can implement the additional features for urban planning, so we can better support the decision-making process for urban planning. Thank you for listening.
Anybody has a question? I think we can have one quick question. Okay, thank you so much, and we'll move to the next speaker. Thank you so much, Mr. Park. I know you are very chilly. It's very chilly and very cold. So we now have the last speaker. He's from Seoul Metropolitan Government, and he will talk about the Seoul Metropolitan Government digital twin, so-called SMAP. Please welcome Mr. Song Ki-sung.
네, 안녕하십니까.
Yes, hello. I'm from the Seoul Metropolitan Government. I'm from the Space Planning Department. My name is Hong Ki-sung. So I listened to all the presentations, and actually the one from Japanese government, the Miss Yuri's presentation, it was very similar to what we are trying to do here. Maybe if we have time later, we can have a separate discussion on this. So I'll go into my presentation. So my topic is also about digital twin, and maybe down below you can see some other words like citizens, and it's because this S-map is the map that we are trying to create to cooperate together with citizens. This is a photo that we have to see together. Maybe this is very familiar photo for many Koreans. This is like a rural scene of Korea. This is called dure, which is like a traditional ritual of Korea. So of course, farming is very energy consuming. So to just boost up the energy, we do this dure to create more cooperative energy and mood. As you already know, in 2002, Michael Greaves first introduced this for efficient management of product life cycle. But what we are trying to cover here is not about one product or a service, limited service, but it looks into the whole city, very complicated object that we have to cover inside this digital twin. And what is different from other digital twins or existing ones is that it has to have the simulation function that covers all the environment security and road and transportation and etc. For efficient management of simulation, there are cases of the UN and Japan that were presented today, and also we have looked into cases in Singapore and the US, and you can see some reference cases in many countries. But this digital twin that is used to manage cities, of course, what is important is the precision of the information. Inside the city, many people are living together, so the result of simulation can have direct impact on citizens. Data, performance, and simulation result all requires high precision and high stability. And here is a question. For this digital twin, if very few number of people, so would it be possible for a very few number of people to create this and continuously manage and advance the system? I don't think it is possible. So that's why the city of Seoul is trying to come up with an answer, and that's why we are coming up with this S-map concept, a cooperative model. There are two concepts that we are pursuing. First is to make the government administration more efficient. There are many decision making or administrations, and by applying simulation, it can make it more efficient. The next is to enhance the convenience of citizens. It can enhance the policy participation of citizens, and also it can allow new experience for users like AR and AI and augmented reality and new 3D content. Those can provide better convenience for Korean citizens. So S-map is created with those goals, and this is how it's constructed. We have the topographic information, underground facility, 2D and 3D information, building and information, 3D indoor spatial information, and on top of that, there are contents for citizens to enjoy. So everything is contained in S-map in just one view. In 2019, for the whole area of city, it was replicated physically, and since 2020, we started to have the information connected, and since 2022, we started to have the simulation. But what we are having difficulties is enhancing those functions. That's why today we are trying to have the collaborative model, where the public and the private sector will come together to enhance this S-map system. In S-map, we have three components. First is the administrative services for the decision making for city planning, fire prevention, etc. And the next is the citizen services to provide information that are needed for the citizens, such as real estate, traffic, and tourism. And third is my key topic, the open lab service. It allows citizens and the research institutions and government institutions to use the information for the development of the system. So why is this open lab needed? Inside SMAP, there is the simulation function that can directly help Korean citizens. And for research institutions and the public sector officials, there are some of those simulations that are not proven yet. And for those unproven simulation results to be uploaded onto SMAP, it is not stable enough. That's why we have created this open lab. So here it is operated on cloud basis for many business people and research institutions to participate, and they can create consistent data by using this cloud system. This open lab pursues these three values. First is accessibility for everybody, and second is the applicability of the technology, and third is the communication among all the stakeholders. So we have to access Open Lab. Just search it on Google, then you can find the link. So on the landing page, you see various digital twin services and content created by citizens. And if you want to go inside the virtual reality, just click this button. And here you see this building and Gwanghwamun area where you are currently at. So it looks very pretty with various texture added. But if the user wants to visualize the detailed layers, then of course you can take out the texture and see the data layer. So of course, just looking at this digital twin would be such a waste. So we offer various functions to modify this digital twin as users want. So here there is a construction site, and as the user wants, you can add any building that you want to envision. It's not limited to certain users. Any citizens accessing our open lab can try this kind of modification. So even those who are trying to participate in some kind of architectural contests, they can try their models on our open lab. For the space analysis, we have connected the system with the city traffic data, and you can see that about 300 traffic spots or points are added or connected here, and you can also download information. And data analysts, what they want is of course to upload the information they have created. So all these space-related formats can be uploaded on our lab. And if there is like energy usage information that the user has for different buildings, here you can see those energy usage information being reflected for different buildings. Of course, high-rise buildings have high energy consumption. If you go a step further, then SLab, it doesn't have a lot of data analysis functions because they are not needed, because there is the QGIS, which is very strong or advanced analysis solution, and they are interconnected to OpenLab. So by going directly from OpenLab to this QGIS, you can plug in all the data and do the analysis that you want here, and the result can be uploaded back into OpenLab. This is for the road surface information. On QGIS, QGIS. If you upload, then you can see the same result reflected on OpenLab. So there is this strong analysis function of QGIS, and by doing that, you can use the information of Seoul Metropolitan Government. So that is one of the first values that OpenLab is trying to achieve. So I just looked into basic functions of OpenLab, and what is even more important is the simulation, like climate change and the urban planning. Those simulation results, they should be applied to OpenLab and prove it before applying it to the QMap, SMAP. And here, it's the climate or weather information generated by the Korean Meteorological Service, and another information that we get from the German Meteorological Service. So these technologies are universally used and universally useful. That's why we have embedded in the SLab so that citizens can utilize this information. Next is the Crime Vulnerability Index. There is the National Space Research Institute. They have developed this. So there are like statistics gathered through CCTV and other security spots. And by analyzing the image, it shows areas in Seoul that are vulnerable to crimes. Of course, this information could be very dangerous if it's opened up to the public. So actually, only limited users can access this information. There is also information about the ground liquefaction prediction, urban inundation prediction, and IoT-based fire monitoring that we have created on our system by cooperating with various agencies. Starting this year, using GitHub, we are publishing or opening up our code so that various other agencies can seek to cooperate together with us. Last value is the communicability. We have the use case gallery where the maps, the analysis results maps, and various implementations made by users are uploaded. So yesterday we had an award, and here these are the works that were submitted by contestants. Last year we had very unfortunate event happening with a lot of people crowding in very small area in Seoul. So in order to prevent such tragedy happening again, here by using this map information, they can find out any high traffic areas or small alleys with many people visiting so that we can prevent that kind of crowd related tragedies happening. So far about 230 Korean citizens have participated in this contest to look into various vulnerabilities or accident-prone situations in Seoul and to find solutions. So why do we need communication? Previous simulations, of course, I think you have seen similar cases in other digital twin cases. But I want to look into two cases that we had in Seoul. First, there is this traffic triangular spot, and actually there was a pedestrian standing in that block, and the person was hit by a car. So it was a tragedy that happened last month, and we actually have done some kind of traffic simulation analysis recently, and we have compared the simulation results of the traffic prone areas and the actual accident. And you can see that this is the area where the accident has happened. You can see this pedestrian block and the red mark and the yellow area. Actually, it shows the land liquefaction danger area. So you can see that already on the simulation, it warns that this area is very dangerous. In Sillimdong, due to just a random assault, one elementary school teacher was killed by just a random hate crime. So we looked into the crime vulnerability index, and except for the accessibility to police station, for all the other indicators, that area ranked the lowest in all the other categories. One student team did the crime analysis simulation, and here it showed similar result for the same location. Then you might be thinking that, oh, this is more accurate than I expected. But what I'm trying to say is not about accuracy. The fact that you can see this in advance, because when there is an event or crime, it's not about cross-checking the simulation. It's about cross-checking the simulation, and if there is anything insufficient, it can do the cross-checking, and we can make enhancements to vulnerable locations. That's what the system can do. I just talked about very bad news only, but I will now go into some positive topics. This is Gwanghwamun, and we're very close to where we are located, and you can see skyscrapers. This is a photo of today, but what would it be like in the past? From the Korea Cultural Heritage Administration, they gave us information to create 3D model of the past landscape of this Gwanghwamun area. Before creating this contents, I didn't know that Yukjo was located at Gwanghwamun. So by creating this 3D image, citizens can learn how Seoul looked like in the past, and they can learn about cultural heritage and properties of Korea. That could be one of the benefits of this 3D image. So I have talked about how we cooperate together with citizens and businesses, citizens and the public sector, and now I'll go into how we cooperate together with private sector companies. So this mobile tech, they create a lot of systems, sensors, and etc. And they install it on cars to gather information about traffic and etc. So for this LMS scanning, what do they need the most? What is lacking the most? That is the information scanned from one spot. But in case of Seoul City, we have LiDAR information that we gather on regular basis. For example, when we gave them our LiDAR data that we have for Cheonghwa, the Blue House, then they create this kind of function. Last year, as we opened up the blueprint to the public, many people can visit the site, of course, but if you have disabilities or you live too far away, then it is not possible to go there in person. So for those people, this kind of metaverse service is created to show them how the Blue House looks like. But would it be only limited to Blue House? Well, for Seoul City, we have the LiDAR information for the whole area of Seoul. So if we can put it on the metaverse as a whole, well, Mobile Tech has created this system for the whole city, where the city management and the details of the city is put on the metaverse. So the company just had less than 1,000 employees, but now it has more than 80 employees, and it is now garnering investment of about $6.7 million. But it's not just mobile tech. There are many other private sector companies. Maybe some of them are familiar to you, and some of them might not be that familiar. There are universities and research institutions here as well. So I was adding their CIs on this slide, but I was so tired, so I couldn't add all the partners' CIs on this slide. But anyways, we have many partners who are working together with us, just like a mobile tech that I just shared. And I am confident that all these cooperations or partnerships will succeed in the near future. Why is cooperative ecosystem so important? It's because the simulation result can be shared and experts will be cross-checking the accuracy and continuously advance the model. And compared to just one-time development, it is like continuously developed system, and it's more advanced than all the other systems. So if you search Open Lab, you will, if you look into open source, then you will see these familiar names. And what is so great about open source is that many people, everyone can access it and share it and develop it. And it's the same for our value at Open Lab. Just like the photo that I showed you at the beginning, this is Ture. This is our traditional culture that we had in Korea, some connection with open source and Ture. So can you relate to the values that we are pursuing at Seoul City? Well, I just want to share this sentence that Helen Keller said, alone we can do little, together we can do a lot. So this is the end of my presentation. Thank you.
Presentation. So we can have one or two questions from audience. Any questions? So don't be shy. Any question? No? I know you are very hungry. So thank you so much, Mr. Song, and I would like to conclude this Digital Twin special session. Thank you so much for your time, and thank you so much for your all the things. Thank you. Thank you very much. And I would like to give you one announcement. We'll have a gala dinner tonight from 6:30. So at the Jongdong Art Center.